Hello, sir. Am I audible? Hello.
Yes, you are.
Yes. So, respected dignitaries, esteemed resource persons, faculty members, and dear participants, a, a very warm and graceful evening to all. It is indeed my honor and privilege to welcome you all to the fourth day of the AICTE Training and Learning Faculty Development Program on Securing the Future, Cybersecurity, Forensics, and the World of Blockchain, which is organized by the Department of Computer Applications, MES College, Marmuli. So, we have been part of this journey, which is truly enriching of our FDP with insightful and relevant sessions from our respected experts. So, I am sure that each day helped us to explore different technologies and to enrich our domain knowledge. So, in this evening, we will continue to expand our knowledge horizon with exciting sessions of our esteemed resource person. So, for the delay, I'm going to introduce about our respected dignitaries. So, in this evening, we are privileged to have two distinguished resource person with us who will enlighten us on the topic privacy preservation tools working on the Onion router browser and security. So it gives me immense pleasure to introduce the esteemed resource person for our today's first session, Dr. Arun Cyril Josar and Miss Shima Shamsuddin. Dr. Arun Cyril Jose, Assistant Professor in the Department of Computer Science and Engineering at the Indian Institute of Information Technology, IIIT Kottayam, Kerala, India. Sir earned his bachelor degree in computer science engineering from Mahatma Gandhi University, India in 2009, master's degree in forensic computing from Coventry University, UK in 2011, and completed his PhD in 2017 from the famous Department of Electrical, Electronic and Computer Engineering, University of Pretoria, South Africa. He's a member of Fact H Lab at IIIT Kottayam, and Sir's research interests include information privacy and security, also home automation security, security-driven social engineering, network vulnerability detection and intrusion prevention, also AI-enabled financial analytics. This session will also be enriched by the expertise of Ms. Shima Shamsuddin, Ms. Client Delivery Head at Prevalent AI Kochi, who works as a cybersecurity domain and data analyst and has experience in both academia and industry. Ma'am completed her MTech in cybersecurity from Amrita Coimbatore since 2021. She has been pursuing her PhD in the privacy domain at IIIT Kottayam under the guidance of our respected Dr. Arun Sir Joseph. So, in today's session, we will explore, as I mentioned, we will going to explore the more about the privacy of Tor browser. So, I, so please join me in the extending a very warm welcome to Dr. Arun Cyril Josar and Ms. Shima Shamsuddin. Over to you, sir.
Yeah. Uh, Thank you, Shima Madhusudanan for joining with me on this. Okay, so we'll start. Let me just share the screen one moment. Yeah. So I hope you can see the screen. Yeah.
Yes, sir.
Yeah. Okay. So just one moment. Yeah. So we can start. Yeah. So first, before we actually move on to our privacy preservation tool, let us just have a look at how or what data is, or what is the significance of data. Uh, I'm sure some of my audience who lived their life during the late 1990s or early 2000s, you remember what video cassettes are, or our VHS tapes are, where if you want to rent some movie, you have to go to a VHS cassette store where you can rent the movie. Okay, so we will first look at a case study of Blockbuster versus Netflix, the same Netflix that we are all familiar with now. So around 2000s, Blockbuster was a giant video um, rental company which had around 9,000 stores and which had almost billions of dollars in revenue. Okay, so their business model revolved around physical stores where customers could rent movies and video games for a fee, and they charge late fee if you are late in giving back the VHS tape. And their model um, uh, um, uh, depended on physical store rentals, late fees, in-person browsing, etc. Okay, so what Blockbuster did is they focused on stocking popular new movies. They often had or made a deal with the movie studios itself, where the movie studios will get some sort of profit from the video with the video rentals as well. Okay, so they were or Blockbuster had popular movies at the time. Okay. So yes, so on the other hand, Netflix, it started as a DVD by mail service. Okay, with a subscription uh, model, unlike with no late fees or no trips to the store or or uh, anything. So their business model revolved around you have to pay a monthly subscription where which the users can rent a set number of DVDs each month for a fixed per monthly fee. You can rent a fixed number of DVDs each month, where it will be sent to you via mail, by post. Okay, so it combined two technologies at the time. DVDs, which were two emerging technologies at the time. DVDs, which was becoming popular around 2000s, and it also combined internet. The what users could do is the users could order uh, their movies online. Okay, and they can also manage a queue in which that is once you have or it Netflix gave user a convenient way of ordering movies. That is, nobody has to go to the actual physical store. They can go to they can go to uh, Netflix's website, and they could order the movie that they want, and they can also manage a queue. That is, after returning this movie, what is the next movie that you want? Okay, so once and they have also Netflix also provided a prepaid return envelope for these DVDs as well. Okay, so yes, so they had robust logistical network where, and they also had a regional warehouses for efficient distribution. Okay, so uh, yes, so John Antioco was the CEO of Blockbuster around 2000, from 2007 onwards. Sorry, from 1997 onwards. Okay, so then you had Reed Hastings, who was the CEO of, or you have Reed Hastings and Mark Randolph. Both of them were the heads of Netflix at the time. Reed Hastings has a background in mathematics, and Mark Randolph had a background in marketing at the time. Okay, so Antioco was the CEO around 1997, where the Netflix or Blockbuster and Netflix were involved in a business battle. Okay, so in around 2007, Antioco was pushed out from the board, or left the Blockbuster. He was pushed out by a corporate raider named Carl Icahn. I'm sure you have heard of the name. If you haven't, it is fine. Okay, so what Netflix did is they offered different shipping options, where they had something called priority shipping, in which people could get DVDs within 1 to 2 days, 1 to 2 business days. Okay, so how Netflix operated was, rather than investing in rather than building a heavy logistical system, they took advantage of the existing US postal service, where they have understood how it actually worked, and they have identified bottlenecks and identified ways to fix it. Okay, so they optimized the postal operations. Then they came up with ways of, or innovative ways of packaging and shipping, with so that the DVDs won't be damaged. Okay, so most importantly, they have they took a data-driven approach. I've explained these things. Okay, so that they went for a data-driven approach. Okay, so which means Netflix employed a data analysis to track delivery performance, identify bottlenecks, and make informed decisions. For example, I've told you users could maintain a delivery queue, meaning once I have rendered this movie, which is the next movie that I am waiting on, or which is the next movie that I would like to rent. Okay, and moreover, Netflix also gave suggestions to people, or since you watched this movie, you might also like these movies. Okay, so they also gave suggestions. So these two key components allowed Netflix for inventory optimization, meaning if you could know that in a particular area these are the movies that are about to be rented, they could stock them in warehouses that are closer to them, right? So they made use of data. Unlike any other video rental businesses at the time, they made use of data so that they can deliver their product to their customers faster and more efficiently than any other competition could. Okay, so in around 2004, Blockbuster or Antioco understood that the future of physical stores are done. So he came up with something called Blockbuster Total Access, in which you could what it is, they just copied this one. They just copied Netflix, and they've just said that you can order Blockbuster movies online, or Blockbuster DVDs online from around 75,000 from 75,000 popular movies. You can rent them online. They will be sent to you via mail, and you can give them back to either the physical store, either in the physical Blockbuster store. Upon returning this, your next DVD, that is your next movie, will be it will be on the way, or you could rent your next movie from the store itself. Okay, it had a few challenges, meaning at the time a significant portion of Blockbuster's revenue came from late fees, meaning people who are late with returning their DVD. A significant portion of their 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 revenue came from late fees. So thus new Blockbuster Total Access completely contradicted or completely cannibalized their late fees, meaning there is no late fees there. Okay. So the store managers whose salary was tied to their commissions, uh, or I mean whose salary were tied to their revenue was against this. So even at the board level, Blockbuster had, or board members were saying, why are you cutting into our existing profit model? So but Andiaco understood that physical stores are not the future, but company failed to actually adapt to this. Okay, and moreover, Blockbuster failed to understand, or they just copied Netflix's web interface and operations of this company. But what they did not do is they did not invest in the data analytics and Netflix and their recommendation algorithms. What Blockbuster just did is they just copied their web interface and operations, but failed to understand the significance of data and analytics at the time. Okay, so the website of Blockbuster was clunky. It was believed to be slow. All those things. So, but once, so it does, or it was also one of the reasons why Antiaco left in around 2007. The board of Blockbuster at the time viewed it as a secondary offering, not as a competition to, or not as a extra offer, or not as a primary business model at the time. Okay, so yes, so you can say that Blockbuster Online failed, or Blockbuster Total Access failed, not because the idea was wrong, but because the company lacked the culture and the strategic and operational willingness to disrupt itself. Meaning, at the moment, it was generating lot of revenue from their late fees, rent fees, all those things, but it was unwilling, or it doesn't understand the significance of data, or it was unwilling to make the switch, or to completely disrupt its own business model and to adapt to the future. Okay, so as you would have predicted, Blockbuster came to an end, meaning the company wasn't profitable anymore. So in around 2000, Blockbuster had around 9,000 stores, and Netflix tried to sell itself to Blockbuster for around 50 million US dollars at the time, and they got laughed out of the room. Okay, so a decade later, Blockbuster was bankrupt and Netflix was worth billions. What changed? Data. Netflix understood the power of user data, analytics, and personalized recommendations, and they changed that business forever. Okay, so later, in around 2007, Netflix reinvented itself as an online streaming platform. As you and I both know, it changed into the Netflix that it is today. Okay, so later they switched on to content production. Even their first TV show that they have ever made, House of Cards, okay, it was also entirely driven by data. Meaning, the show went into production around 2012. At that time, their decision to make a political drama they knew that political dramas were popular at the time based on data, and they also knew that Kevin Spacey, who was the popular or who was the lead in the show, uh, resonated with their audience at the time. And David Fincher, the director of the show, his direction style was also popular. So their decision to make this show was entirely driven by data. So that company understood the significance of data, which changed their or which significantly improved or enhanced their business model. Okay, so I've given you this example or this case study so that you understand the significance of data. Now let us look at the privacy, or how significant does again privacy. Okay, so I'm sure you have heard this particular argument. I have no privacy concerns because I have nothing to hide. Well, it is not as simple as that. Imagine that you have a health insurance. Okay, you are paying X amount of money as health insurance premium each month. Okay, and you said that you are a non-smoker, non-drinker, and suddenly you have ordered some cigarettes, or you have ordered some alcohol via Amazon, or you have posted pictures of yourself drinking, or you have posted pictures of yourself smoking and drinking on Facebook or any of the other social media platforms. Okay, do you think your health insurance provider would really like to know how you live your life, or whether you are a smoker or a drinker? Why? Because their profit margins, or your health is their concern. Why? Because their profit margins depends on how healthy you are. Okay, so yeah, so uh, and does any of you think that either Facebook or Amazon or any of the other social media platforms will not share your data? If you are thinking that, you would be wrong. Their entire business model or their entire revenue is from sharing data. Okay, so your health insurance provider would very much like to know how you live your life, and if based on such data, your insurance premiums could go up. Okay, so yeah, so yes, and I'm sure you are familiar with our universal payment interface, our UPI. Okay, so since most of you are using UPIs, or most of us are using UPIs. Okay, uh, let me give you one example where imagine that any one of the shops close to your campus here, close to IIIT Kottayam campus, we have a stationery shop. Okay, imagine that stationery shop. Now, that shopkeeper or that shop owner, since most of his customers are students, they pay via UPI. Okay, so to have a UPI, you need a bank account, right? So he has a bank account for his UPI payments, and most of his his business is actually happening via UPI. So he has to pay. I mean, the payment is through the bank. Okay, so now imagine that he want to apply for a loan. That is, he want to apply for a loan and expand his shop. Okay, and he is going to a bank, or he is going to the same bank asking for a loan. Now, the bank would like to assess his credit risk. Okay, his credit risk, meaning how risky is the loan to him. They at the moment, what they'll do is they will look at your your credit score, your CIBIL score, and check whether if your credit score is good, your interest rate will be low. Meaning, if the bank has to take more risk in giving you the loan, that is, the bank is not sure that you will repay the loan on time, you will be charged more interest. Why? Because the bank is taking more risk in giving you the loan. Okay. So here in this case, the bank has clear visibility over his business. That is, the bank knows how much money he is actually making each week, each month, each day. And since you are getting the money through bank, you are most likely to pay your vendors also via bank. So in effect, the bank will have a clear visibility over your profit margins. So the bank can clearly assess your profit margins. That is, will you be able to pay the interest each week or each month? Okay, the bank will have a very clear visibility over it. Okay, so again, it has nothing but data and nothing but analyzing data. And now think of the bigger picture. The bank has visibility over a stationery shop which has an inventory of, say, 5 lakhs or 2 lakhs, which is close to a national institute, and the bank knows that this shop has a revenue of X each month, each week. Okay. Now the bank can use that information to give out loans for other shops as well. Like, you get my point. That is, a shop that is close to a national institute with X number of students is generating this much revenue each month, and based on that they can assess the performance of, or the credit worthiness of other shops that are close to some other national institute. Okay. There are various other factors in play, but I'm just giving you a whole idea. And I'll tell you something else. Like, all of us are using multiple UPI apps, right? Whether it is PhonePe, Google Pay, Paytm, Amazon Pay, or whatever other thing that you are using. Can you imagine the quantity of data that each of these apps have on you? That is, they'll know from which shop you are buying, or from which location that you are buying, and how much you are paying. That is, if I frequently buy from a sweet shop or from a chocolate shop, what can you imagine the amount of analytics that they can do on you? So this is a message that I received from Google Pay. Yeah. This is the message that I have got from Google Pay when I was doing. So they were asking me to get better rewards based on your spending habit. That is, to get better rewards, you are. They asked me to switch on location, additional information like location. So in effect, your Google will know where exactly you are making the payments and how much you have paid. Based on that, I can figure out what I actually took from there as well. Okay, that is an interesting case study for some other day. Okay, so yes, why am I talking about UPI? This is the data from our National Payment Corporation of India. You can visit the page and see. Okay, so here you can see the volume of UPI transaction is just going up from August of 2024 till August of 2025. You can see the volume of transaction is just going up and up and up. Okay, and the value transacted is close to that. Okay, so yes, So we'll move on. A meme about. So I'll tell you about one more fun project that we have did during our with our UG students. So we analyzed Twitter data. We analyzed around 1.7 million tweets uh, that were. Uh, we collected it from the Twitter data set. We collected it. I mean, we worked on Twitter data set in from 2020 Twitter data set where Joe Biden and uh, Donald Trump competed in U.S. election with which Donald Trump lost, with which Joe Biden won. So we have analyzed data on that, and based on the tweets, we were able to classify them as extreme Republicans, moderate Republicans, extreme Democrats, and moderate Democrats. So we did a study here, and based on the tweets we were able to identify the political leniency of uh, the users. Okay, and we were also able to predict uh, what stands or if the views of a particular party changed on this particular topic, this many number of people, or there is a probability that this much number of people will switch from one cluster to to uh, to the other. Okay, it was a interesting study. You can read about it in the paper here. Now that we have said about the challenges, I mean, about the privacy, or the significance of data privacy, we will see what are the solutions. The one solution would be to use a VPN, a virtual private network. We'll briefly or we'll briefly see how it is actually working. Okay. So in VPN, once you have identified a VPN service provider, whether it is ExpressVPN, NordVPN, Surfshark, or any other popular VPNs that are out there. Once you install their app or their application in your system, you have basically established a secure tunnel between their server and your system. Meaning, the VPN application will basically encrypt the data from your system, and it will be sent through the your ISP over the internet, and it will reach the VPN servers. From there, uh, your VPN server will decrypt it. It will visit the page that you want. It will give it back to the VPN server. From there, again, the data is again encrypted, and it is sent back to you. So the advantages, if you are eavesdropping on somewhere in between there, since the communication is actually encrypted, you can't make sense of it. Okay, these are some of the popular protocols that have been used. Level 2 tunneling protocol that is popularly used by the ISP to actually enable VPN. Then you have IPsec, your IP security protocol to provide security for that. Then you have Open VPN to establish an end-to-end encrypted connection there. Then you have SSTP, which is Windows proprietary protocol for VPN. Then you have Internet Key Exchange version 2 for re-establishing the connection if it is lost. Okay, so but the catch is, you are keeping an awfully lot of trust on the VPN server, or on the VPN service provider, not to keep logs. That is, what if your VPN service provider is actually keeping logs? Then it beats the whole purpose, no? That is, what if all the pages that you are visiting, and the VPN server is actually keeping logs? That is, on this day, this time, this IP has actually visited this page. That kind of logs, if they are keeping, then it beats the whole purpose of VPNs, right? So how can you trust, or how would you know which VPNs are good or not? Again, I don't have an answer for you there. Okay, there are famous cases out there that you can look at, that some VPNs help the government and they provided logs, some don't. Okay, so yes, so VPNs are, the server itself is actually cheap to, it is not that expensive to actually set up. Most VPNs, they spend a lot on marketing, meaning promoting their VPN. Yeah. So anyway, the next solution would be Tor, onion routing, or to use Tor. So in Tor, we use layers of encryption, just like you see in a in a in a onion, as you can see here. Okay, so Tor was initially proposed as it was initially developed by the US Naval Research Lab in the mid 1990s by employees Paul Siverson, Michael Reed, and David Goldslack. Okay, to protect US intelligence communication online. Okay, it was patented by the US Navy in 1998. Okay, later computer scientists Roger Dingledine and Nick Matheson joined them. So in around 2002, to develop what has become one of the largest, best known implementations of onion routing, popularly known as Tor. Okay, so yes, so later, the project was further developed by DARPA, the Defense Advanced Research Project Agency in US. Okay, so later the Tor later the Naval Research Lab, they released the code for Tor under free license. Okay, so at the time, Dingledine, Matheson, and five others founded the Tor project with financial support from Electronic Frontier Foundation, another privacy watchdog that is out there. Okay. So and several other organizations. So this is the base paper for Tor. If you want to read about it, as you can see, the authors Siverson, Goldslack, Reed. Yeah. So yes. Now let us see how the Tor is actually going to work here. Okay. So originally, when you have to download the Tor client, which I'll give you the URL where to actually download it from. Okay. So when the client select a set of nodes from a list provided by the directory node, that is when a Tor is actually establishing connection, you are selecting a set of nodes. I'm going to call this node A, node B, and node C. Okay, so so initially you are establishing a connection, or you are selecting a set of nodes from a list. Okay, from the directory nodes. So you are going to select 3 nodes. Okay, now you are using asymmetric key encryption. Asymmetric key encryption here, meaning you have a private key and you have a public key. Key here. So yeah, so as you know, the public key is basically known by everyone, and the private key of node A is only known by A, and the private key of node B is only known by B, and the private key of node C is actually only known by C, and the public key of nodes A, B, and C are shared to the client when you establish this link. Initially, when you actually establish a connection, that is when you select those nodes, their public keys are actually shared with the uh, the the client here. Okay, so when the client wants to communicate something, that is, if the client wants to say wants to visit www.youtube.com. Okay, so the client will first triple encrypt that particular message. Okay, his data packets will be triple encrypted, meaning it will encrypt this data packets with the public key of A, with the public key of B, and the public key of C, as you can see here. So, and it is sent to node A. Okay, so at node A, it is also called the input node. So at node A will see that particular message, and it will apply its private key and decrypts and removes one layer of uh, encryption. Okay, it takes out, or it removes one layer of encryption. Still, the message doesn't make any sense. Why? Because it is still encrypted. That is, you have two more layers there. Then A knows the address of node B. Okay, and so A knows, or node A knows, where the packet actually came from. That is, which is from here, which is from the client, and it knows the address of node B, and it forwards the packet to node B. At node B again removes the next layer of encryption using its private key. Again, the message doesn't make any sense. It is still encrypted. So node B forwards it to node C. Okay, node B knows the address of node A and the address of node C. That is, node B knows where the packet came from, which is from node A, and node B also knows where the packet has to be sent to, which is C. At node C again, node C's private key is used, and the next layer of encryption is actually taken out, and node C can see the message www.youtube.com. Okay, and node C will basically fetch the page. It will go to YouTube servers, and it will fetch the page, and upon coming back, node C knows that this particular message has to be sent to node B. Okay, it will encrypt the message again. It will use its private key to actually encrypt that message again. Okay, so node C encrypts the message. It is sent to node B. Again, node B encrypts the message with its private key. Again, it is sent to node A. Node A again actually encrypts the message with its private key. It is again sent back to the client. Okay, at the client side, the client uses the public keys of node A, B, and C to actually decrypt the message and see the page. Now, how does this provide anonymity? Well, imagine that you are eavesdropping here. That is, you are eavesdropping on the communication between nodes, between the client and node A. Okay, your entry node. Well, you know that the message is triple encrypted here, so you can't understand what the actual message is, but you would be able to tell that the client is actually using Tor. Okay, now imagine that you are eavesdropping here, or you are eavesdropping at node C. There you can see that it is visiting www.youtube.com, but you don't know who the actual sender is. C doesn't know where the actual message came from. C only knows that it came from node B. C doesn't know where or who is the true or who is the true client here. C doesn't know that. So you will be able to see the messages actually or what the actual request is, but you won't be able to say who has actually made that particular request. So if you are eavesdropping here, you can't see the message, but you can see that B and C are actually communicating something. And moreover, your bridges or your Tor bridges, that is nodes A, B, and C, might be in different country. Okay, and these nodes A, B, and C, it might be the entry node, exit node, and intermediate nodes for hundreds of other different connections as well. So you can't just analyze these nodes and actually figure out what the actual traffic is and where it is actually coming from. Okay, again, Tor is not 100% secure. You have a timing attack. You can explore that.
Sir, one question, Mr. Arun.
Yeah.
Actually, in Tor, you're good. Actually, everything is good. What you're told.
Ah.
But definitely, moving with so many systems, speed will be reduced. Speed will be definitely reduced comparing to VPN.
True.
VPN will be speed. We have to compromise for that.
True.
Correct?
True. Yes. True. That is, it won't be as fast as when you browse. If you have used Tor, you might. Yes, you might have experienced that.
I'm asking you because you're told so many systems going.
True.
Definitely slow. It will be slow. Data transfer will be slow.
Yes, true. It is the compromise you have to make for providing this privacy. Okay,
and
but
also in the last exit node, again, the encrypted may be decrypted. Security, there also some problem may become in the last exit node.
In the exit node, the security may be compromised.
Exactly. Decrypted. In VPN, that is not the case.
No, your argument is at the exit node, I might be able to see what www.youtube.com. That is yes, true. But you don't know who actually made that request. That is, the client is actually it is not known. Like, you can only know that node C is actually making a request to www.youtube.com, which is a Tor bridge or which is a Tor intermediate node. That is all you can see.
Okay.
But the true identity of the client is actually not known.
Thank you, Arun.
But the question is, why only 3 nodes? Why can't I use 4 nodes or 5 nodes or 6 nodes? Well, I think you have already answered the question there. The challenge is time. Okay. If I use 4 nodes, obviously my privacy might be good, but it will take more time to fetch the page. Okay, so 3 is the sweet spot where I have data privacy, but I have that time, or it is the sweet spot. Okay, and one more thing. Don't think that Tor is 100% secure unless and until you are coming up against a nation, like an intelligence agency of a nation. You are relatively good, but Tor is, again, you can look up a timing attack. Okay, we don't have the time to actually go into it. So you can download Tor from www.torproject.org/downloads. Don't download it from anywhere else. Only download it from here. There are various corrupted or various, I wouldn't say corrupted, various log enabled versions of Tor. So only download it from here if you are planning on getting Tor. I think I've taken more time. Shima Madhusudanan, over to you. Please carry on with the tools. Let me stop my sharing. Yeah.
Thank you, Arun sir, for the opportunity. Thank you, NVS College. So Let me share my screen. I hope my screen is visible.
Yes, 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 yes. Yes.
Okay. So as said by Arun sir, we just saw how a VPN works. And also he mentioned on security and privacy. So VPN basically is something that can guarantee privacy. With VPN, we get a secure connection. We become anonymous. We have the freedom to go and fetch into geo-restricted websites too. If not with VPN, if we are using a public Wi-Fi, there are chances of attacks, or there are chances of uh, attackers sniffing into our private data or personally identifiable information. That is the place where VPN has a role to play. Now, as he has discussed on it, I'll move with the tool that we can currently use, which is Proton VPN. So, okay, this is the site for Proton VPN. If you just type protonvpn.com in your system, you will get a screen like this, wherein you can download for your preferred systems. Now I'm using Mac, so I have downloaded it for Mac OS. And can I show the working of Proton VPN? Yeah.
Yeah.
Yes. Yeah, 1 second. I think I am restricted to share only the tabs within here. Let me just check 1 second. 1 second, 1 second. Okay. Okay. So this is how a Proton VPN looks like. Currently, I have not connected, and my IP now is 223.181.12.144, whatever. So I'm just quickly connecting it. This is a free version of Proton VPN. If we want to select a country and then go by, by that IP address, we can, but we should have a paid Proton VPN. So now I'm quickly. Okay, for some reason.
Yeah. It should be fine now. Shima?
Hello? Unable to hear anything.
Yeah, I think she has some network issue. She is reconnecting.
Okay.
Yeah.
Am I audible?
Yes. Please go ahead.
Okay.
Yeah.
So once we get connected to Proton VPN, we can open the browser and go to whatismyipaddress.com. So it will show the IP address which is destined with that connection, and then we would see that it is in some other region. So the benefits of this is that we become anonymous throughout the searching or throughout the browsing period that is being used by us. So now what is happening is when I'm trying to connect, I'm getting disconnected from the Google Meet. Okay.
Okay, that was okay. Yeah, okay. Yeah.
So this is one tool, Proton VPN. So you can see in the screenshot, like when I type what is my IP address, my IP address has changed to Los Angeles or California. This is the experiment that I had done before. Currently, due to some technical reason, it's coming out of the Google Meet, so I'm not able to continue. Okay, now let's go to the next tool. Next, it has many layers. So the one which I talked about is Proton VPN, which is for the network and communication. So the next one is end-to-end encrypting messages. Currently, we have this feature in WhatsApp, and the most trusted or most privacy policy kind of abiding kind of methodology for messaging is Signal. We did have Signals to once when we all restricted using WhatsApp. We all had downloaded Signal, if I believe, when it was around 2020 or 21. Signal is kind of an app wherein it ensures end-to-end encrypting. WhatsApp too has. So these are various levels wherein we are not providing security, but where we are privacy control, wherein we can become anonymous and no other third party will get to know our personally identifiable information. Now, the next tool is Privacy Badger. So Privacy Badger is something that makes hidden trackers visible and blocks them. That is, for example, if you are going to CNN.com or timesofindia.com, a kind of news channel, we are being tracked by hidden items which we are unaware of. So if we install Privacy Badger, it detects these trackers automatically. So it can be installed as a extension to our Chrome browser. Maybe I can show you that. So Privacy Badger Chrome. So see, I have got private. I hope my screen is visible.
Yes.
So this is the Privacy Badger. We have a watchdog as the symbol for this Privacy Badger. Now, before using Privacy Badger, if I go to CNN.com, see, I get advertisement and many trackers tracking us without we knowing about it. But now when I install or when I add in Privacy Badger, I'm adding it to Chrome and I'm adding its extension. Okay. Now I have added. Now when I go to CNN.com, see this? When I click here, that's it. Okay. Now when I click here, I can see. Oh my God! 1 second.
Yeah, can you try now?
Yeah. See, there are 32 notifications. So saying that there are 39 potential trackers being blocked, which was not seen before. We didn't know that we were being tracked with some kind of a tracker. So now this 39 potential trackers are blocked. Now, green means that a particular tracker is allowed, means it doesn't have any cost to our personally identifiable information. Yellow is a thing that says that we need to block the cookies, and red means it is fully blocked. Now you have seen that after I installed or when I used Privacy Badger, the change that happened is I am now able to understand that acdn.adnx.com, ib.adnx.com. These are the sites which were tracking me unknowingly, which I wouldn't have known without the tool. So there are 39 potential trackers being blocked with this privacy badger. Hope I'm clear. Okay. Now I'll move to the next. So in short, privacy badger is watchdog. Like while you browse, it follows us and it will let us know whether we are being tracked or whether we need to block any site or whether we need to make it as yellow so that we can block the cookies in the later phase. So it has another characteristics, like it was not like this before. I mean, the previous year it was not behaving like this. This year it has started integrating by learning the behavior of the user. So if it actually, the watchdog behaves in a way that we browse. So that is one feature that has been added to Privacy Badger, and it is now self-adaptive. So that is about this tool. Now coming to the next tool, that is NoScript. Another tool, similar kind of Privacy Badger, is NoScript. NoScript has these options like default, temporary trusted, trusted, untrusted, and custom. So NoScript will give you a warning if there is a potential cross-site scripting attack being happening in your system. It will also warn you on potential identity leak. Again, this also can be installed via Chrome extension. So if I show you NoScript for Chrome Web Store, I'm adding extension. Now NoScript has been added to my Chrome. Suppose now I'm going to Times of India or any website that has lots and lots of advertisements and other items that people usually see through. See, now in NoScript I can see that there is default blocked sites or default that is by default it has been mentioned as a something that is tracking us or something that is taking out our personally identifiable information. And when it is symbol as, it is trusted. So there are few things which are trusted, but there are others which have this warning symbol with S. So these are the two tools that can help us while browsing over internet. Now, I talked about communication and network privacy now, wherein we just saw on Proton VPN and browsing tools can enable us to be anonymous. Then the next level of privacy is data level privacy. As in, you all might be knowing that US Census Bureau started collecting data in 1850. 1950, they started computational automation, etc. on that data. By 1972, they got to know that it has or have some personal information, which when leaked can cause issues. So from 1972, they have started initiatives in bringing privacy, or rather it was not coined as privacy, they started inducing noise to the data. So in 1974, US government is passing the Privacy Act. 1980, there is a paper from Dorothy D. Denning on anonymization of data. 1993, synthetic data generation kind of a concept was born. Moving forward, by 2007, we got into a position wherein we categorized anonymization to multiple techniques. And finally, in between, in 2006, Cynthia Dwork published an article on differential privacy, where the author tried to combine mathematical formulation with noise addition to preserve the private data or personally identifiable data. So this is the history of applying data level privacy. Though it started in 1950, it has gained importance in the 21st century. Optimization technique, which you all knowing about: masking, pseudo-anonymization, generalization, data swapping, data perturbation, and synthetic data generation. So what it all does is, we don't want the entire data changed, or we don't want the entire data to be protected. What privacy essentially means is, I do not want my name, or say my age, or my gender, or my postal code to be given to somebody without my consent. So census data, as you know, will contain all these kind of data, but the person or the user doesn't want his data to be publicized. So for that, all these techniques can be used. Data masking is wherein you mask the data for which there is an importance for. Pseudonymization is not complete anonymization, but you are anonymizing certain things. Now, what is anonymization? Anonymization is hiding in the crowd. So I'll give an example. Suppose that we have a table wherein we have ID, age, SIP, and disease. So if I just say age is between 0 to 20, 7 falls under 0 to 20. It is kind of a generalization. Plus, I'm adding something star kind of a thing to hide the zip code. So in this way, any third person getting to know this final table wouldn't know which aged person living in which location has flu, or that personal data is hidden from the user. So this is K anonymization technique, which was the first proposed idea for privacy. The next is L diversity, similar to K anonymization, but we have a grouping kind of a system here. So here you can see with respect to postcode and age group, they have divided into two. 476 stars. All these starts with 476 stars, and the rest starts with 479, and they have something other than that, which is similar, that is age group. Under 30 comes in Q1 group 1, and over 40 go to Q1 group 2. So this is the technique they use in L diversity. Both anonymization and L diversity are generalization or suppression techniques. The next one is T closeness, more advanced version of K anonymity or L diversity. Here too, you can see that they have grouped with equal distribution. 476 star star. This box has 3, and this box also has 3. They have skewed the table in a way that they hold in an equivalent class. So that is the concept of T closeness. Now, if you are interested, you can actually try out this particular Tomedus.com. Let me see if I get connected to it. Yeah, Tomedus.com. So this is actually a data anonymization tool. So if you have any input data, you can try a sample text over here, and then you can see the output text in your right bar, wherein your name, suppose say Shima, if I'm giving it as Shima, in the output it will come as name1. Okay, so this is how it works. You can also upload your file and then anonymize the data. So let me see if it gets uploaded. For some reason, it's not getting uploaded now. Okay, I'll get back to this later. Okay, so that is one tool which you can use online to anonymize any sensitive data. But again, since it is an online tool, it's not much appreciated because again, it is online. We are giving our data to an online platform. But there is another platform, but you would need Java, jar file, etc. for that. That is Amnesia by OpenArray. It is a it has very tool It supports k-anonymity and it has visual interfacing so that you can adjust, like you can say that you need only these many portions of your data to be skewed, or these many data of yours want to be in star format. So this is another tool called Amnesia. It's developed in Europe. So you can have a try with that too, but sensitive data uploading should be carefully done. Now, this is my area of research where it is differential privacy. As I said, differential privacy was wherein a mathematical formula had brought up for adding noise to a personally identifiable information. So I'm not going into the details of the mathematical equation here. However, I'll just tell you the concept. Suppose we have 3 data owners and they need to send data. So there's something called as local differential privacy, where the data owner, the custodian of data, that person can add noise to the document or data and send it to an aggregator. And then while the final result come, when we query, we get a result that is actually perturbed in the sense which is add noise. So this algorithm, or the differential privacy algorithm, is maintained in a way that the third person or the person who is querying would get the essence of the data. However, he will not know the personally identifiable information. For example, if I say in a particular location, I have 30 people identified with cancer. So I need that exact data for doing a machine learning kind of a work. So differential privacy is formulated in a way wherein you have this 30 as 30 there, but it will not give the individual data of who is having cancer, or which 30 people have this cancer, or where are they located, or what their address is, or what their PIN code is. That will not be given. So that is where my research lies in. The next is global differential privacy. This is a variant of local differential privacy. In global differential privacy, what happens is you have a central server or a trusted data center which will add this noise, and after adding the noise to the data, this data gets perturbed and then it will be sent to the user, whosoever is accessing it or whosoever is querying it. So what happens is this trusted data curator is actually adding a noise to it, and similar to local differential privacy, the third person who is querying it will not be getting the actual data. In fact, he'll be getting the statistical data, which is some more or less right, but the other personally identifiable
Excuse me,
data.
ma'am.
Yeah.
Excuse me, Shima, ma'am. Ma'am, I think
Yeah.
you have some network issues because your audio is breaking, ma'am.
Oh my God. Can you
No,
hear me now?
It was fine. Only
Ma'am, your audio is breaking. I sent a message already.
Yeah. Is everyone facing the same problem or just you? I can hear properly.
maybe you can switch off your video.
Yeah. 1 second. One second. Can you hear me now?
Yeah, you're audible. Maybe you can share your screen and switch off your video. Yeah, you've already switched off your video.
Yeah. Okay. So I'll share my screen again. Can you hear me
Yeah.
now?
Yes, ma'am.
Yeah, now
Parvati,
it's
yeah.
clear, ma'am.
Okay.
You're audible.
Okay. So till where did you hear?
You can continue, Shima.
Okay. So
From global differential privacy, you can start. Yeah.
So in global differential privacy, what happens is data owners will send their data to a central data curator, and from there the noise will be added in a way that our personally identifiable information will be hidden. And the query, the person who queries will get a data that is perturbed or added with noise. So as I mentioned before, it works with the principle of epsilon delta dp, where this delta is actually a trade-off between privacy and accuracy. And epsilon is the privacy budget, or a mathematical value that governs how much noise is to be added to protect our personal data. Okay. Now, next is, so now we have talked about communication and network privacy. The next one was data level privacy. And now the third one is user level privacy. So the distinction is, in user level privacy, I would like to point out that we would be having multiple domain, multiple accounts, and which we would remember or store it in Google, etc. Right? We'll be using one email ID password combination for Gmail. We would be using another Gmail, another username password for Facebook, another for Instagram, or whatever. So, and we would be using the same system, same Chrome browser for that. So it's very hard for us to remember all these passwords. So ideally what we do is we'll ask the system to remember it for us, and then we log in. We'll just tick on remember me all the time, and then we go and fetch the browsers or fetch the sites that we want. But we won't be enabled with privacy in such cases, because we have given all our data there. Our password is being stored somewhere. So for that, we have a solution which is called as Bitwarden, which is free open source tool, or KeePassXC, or 1Password. 1Password is the most efficient one, but it is paid. However, we can always go to Bitwarden. I can just show you how it works. I may not be completely show the tool as because it needs my password, etc. So Bitwarden Chrome extension. Okay, so Bitwarden password manager, I can add it.
Ma'am, we can see the slide already.
Now?
And now it's fine.
Yeah.
Okay. So, okay, so this is the Bitwarden site. So in Bitwarden, you need to create a free account. Okay, you create a free account, and it will provide you with a master security key. Now, I cannot share the screen and show it because it has connection with my email ID, but you can try it whenever you're available. I mean, whenever you are free, just type in bitwarden.com, create a free account, link it to your email ID, and use this as Chrome extension. This is similar to how we used Privacy Badger or any other tool for that matter. So when we use this Bitwarden, it has a master security kind of a thing. That means you need to remember only one password, that is master password. So you can lock all other passwords under it. So it's kind of a vault. Okay, so you can actually give your master password over there, and the rest will become like a single sign-on. The same like how we are browsing, but with an additional layer of privacy. Currently, we browse just by keeping our information not in a private mode. So when we use this Bitwarden, we can actually assure that all our passwords are privately protected, or at least our details will not be given to others. The best one among this is 1Password, but as I said, it is paid version. So I have mentioned here how it works. You can install Bitwarden browser extension into Chrome or Firefox. You need to create an account and then log in. Then go to Gmail, sign in, and there it will again ask you for a strong random password. You can give that, save it securely, And next time, the other passwords auto-filled. Somebody raised hand.
Yes,
Okay.
ma'am. Ma'am,
Yeah.
how can we be sure that this Bitwarden or any other keylogger, which we are telling a wallet which is going to maintain our password, is not sending our passwords to any other servers? How can we be that sure?
No, no,
Because it,
it works in a different way. It's not sending into any other database store or anything. It is specific to your Chrome and your system.
no, but
It
that is only
won't.
I'm asking how, because we are downloading it as a third party software. Uh, so how can we be sure that it is not sending the data? Like when we are doing the session day before yesterday, we are seeing that the passwords are being incorrectly sent to, or the data was being incorrectly sent it to some other website using this explorer.exe services, from which the services were being started and it used to send the data.
Hmm.
So when we check such kind of things, when we install such kind of keychains, because you also use Mac, I also use Mac. Mac is
Hmm.
also giving a password and keychain kind of option. Okay.
Hmm.
So
Yeah.
in Mac, in Apple, we use this to store our password, then we are very much sure that Apple does not leak the password. Okay.
We are not sure, right? Apple also
We are
can leak.
not sure. It can also leak, but Apple is still secure than Windows or any other operating
So,
system, Android or whatever.
I understand Mac is still secure, then yeah, that is true. But however, Mac also has privacy issues, right? But here what happens is they are storing it in an encrypted vault within your browser. As you said, yes, there are bits of security. As you said, yes, there are chances that it might get, but then too, we are being anonymous by using these password managers in Chrome. That is the point. Like if we are using Mac Vault or say Windows Azure Vault or whatever, what happens is we are not being anonymous over the browser. They keep track. I mean, we ourselves have experienced that if we go and click on an advertisement, then we get reels of that same advertisement again and again, which means they are tracking us, right, personally. But in this case, that would get out of it. As you said, yes, there are chances of security breach. Howsoever we try to protect it, yes, there are chances of being breached. But this is an area where we are focusing on anonymity,
Oh, okay, ma'am.
where it's not redirecting to, or they are not capturing our personal interests or our personal, name or whatever. Whatever
Okay.
identifies us will be protected. Okay, so that is about password managers. Now, next user level privacy tool is for, again, being anonymous and going about with a protection overlay is Ghostery or Disconnect or DuckDuckGo. These are which detect and block hidden trackers, like how I showed before. And
Shima, maybe you can share your presentation. Now it is still on Bitwarden.
yeah,
Yeah.
so the next level of, or the next tool that works with protecting our browsing is Ghostery, Disconnect, or DuckDuckGo. So it actually detect and block the hidden trackers like ads, analytics, social media, etc. And it will show how many trackers a site tried to load. Maybe I can show you that. 1 second. 1 second. Ghostery extension. I hope you can see my screen, entire screen now.
Yes.
Okay. So this is Ghostery tracker and ad blocker. So I'm adding it to Chrome. Okay. So I have added its extension. Now, okay, so it does ad blocking, anti-tracking, and enabling it. Now, if I go to some site, which site you want me to go?
Any news site is fine.
Okay. So in this, if I go and see Ghostery, we can see that there were 8 observed activities. So we are being observed by 8 advertising sites, 2 hosting sites, and 2 unidentified sites. And 6 trackers have been blocked by Ghostery. So allowing all these actually give you the benefit of privacy or being tracked by someone else. So that is the whole point. And if you want to remove it anytime, if you want to disable any of these trackers like Privacy Badger, Privacy Badger has another set of statistics to say. So NoScript has another set of statistics to say. So if we are equipped with all these, then we can be at least, some percentage assured that we are not being tracked by somebody. And we can always remove whichever we don't want by just clicking on remove from Chrome. Remove it. And whenever you want, you can use it. These are all open source extensions that can be used with browsers. So that's all I had to discuss today.
Yeah.
If you have any doubt, yeah.
Yeah. So any questions from regarding any of the topics that we have discussed?
Yes, sir.
Yeah, please go ahead.
Sir, for the last 3 days, what we were seeing were kind of suppose we are cybersecurity officers and kind of police people who are trying to find out if there has been some kind of malicious activity. Today, what we are learning is how to save our data. Okay, by not getting affected by anonymous websites or hackers.
Yeah.
But the same thing has been learned by malicious people also. So they can also protect their data, okay, so that they do not get caught. So whatever this old layer structure, our OSA models, and what we have learned is that whatever we do, our MAC address is also going, our IP address is also going. So these were the kind of things that were prepared, means the softwares or the whatever the network softwares were written in such a way that these were the things which are always going to get that your MAC ID and your IP are going. So now the hackers have or the malicious people come with ideas how to manipulate the MAC IDs or how not to send their IP addresses. So what we have learned today, so if a malicious person also tries to hide their data, so being a police officer, how would somebody try to go and find those things? That whether he is a hacker or a real person or a good person is trying to hide their data. So there should be some kind of thing.
Okay. I guess the question is these tools could be
The question is how would try to you hide your data? There should be a tool which is going to get your data if he or she wants. Means the government wants some data, then they are able to get the data.
Oh,
How much powerful tools you use? That is the main.
oh yes. I've been working in privacy for the past 10 years, and I can tell you that the best we can do is manage data privacy. Like in the sense, if you try, or first of all, there is no such thing as privacy over the internet. Okay.
Yeah.
If
Correct.
you try hard enough, the only question is how much time, how much effort are you willing to invest to actually break in, or am I worth, or whether my data is actually worth that much for you to spend that much time, that much money, that much energy to actually break into. Okay. So if you are thinking you are develop some sort of tool or some sort of new device that can keep all your data private, you would be wrong. I'll tell you why. Because if somebody says that, okay, this device is the most private device in the world, the next logical step for any intelligence agency out there is to break that thing. So they have added incentive or motivation to break into that particular device or technology. Okay, so that would be the logical answer or the logical explanation. I hope I have answered your question, or you were asking something else.
No, sir. Exactly. I was asking the same thing, that there should be some way that, however you try to protect your data once you are on public internet.
Oh,
So there should be some intelligent way to get to your data. Correct?
I mean, like, I wouldn't say intelligent. I would say that, okay, I don't want to talk about things that I can't back up, but I can logically make guesses. But okay, like, just keep in mind that there is no such thing as complete privacy when you are in internet or even in air gap systems. There is no such thing as complete privacy. Okay, and please keep in mind that what Shima and I, what we are trying to do is we are trying to provide or make it difficult for people to get to your data.
Yes, sir. That's what I exactly, because
Yeah.
like initially people used to protect their homes by simply using a lock. Then the lock, there were duplicate keys, so we came with new computerized lock. Now we came with CCD. So always we try to improve the level of security, and somebody is going to breach them someday.
Yes,
Okay,
and
correct.
I would argue that with the lock and key, you have to be physically there to actually break in. No, so with your online data, you can be anywhere in the world, and you can. I would say that your privacy is even less, or your data
Yeah,
security is
correct.
even less compared to a traditional lock and key.
Yeah, correct.
Sir, may I ask you a question?
Yeah, please.
Maybe, I mean, my question may not be related to the content exactly,
Ah.
but when we're talking about data security, we have heard the term called blockchain.
Ah.
So, can you share your view or thoughts about this? I mean, how blockchain will secure our data? Because we have heard that maybe in future, data can be secured with the using help of blockchain that will help us to anonymize data, or you can say the data can be secured, right? Related to the relational database which we use in nowadays. So, can you, if you say something about blockchain and data privacy, something if there is correlation?
Okay, so as far as blockchain is concerned, blockchain, you know that all the transactions that are done using a blockchain, it can be tracked, right? With a wallet ID, if you are transferring money, if you have the wallet ID, you can track it to. I mean, you can track the source of the money. So, but what blockchain offers you is that say immutable property, meaning the data can't change. But from a privacy perspective, I wouldn't say blockchain helps with data privacy. Maybe it is good. It brings in transparency as to if certain money is transferred to somewhere, if you can track the wallet, or if you can identify the wallet ID and pin it to a particular person, you can say where that particular wallet ID have actually transferred money to. Okay, from a perspective of privacy, blockchain is not your friend. From a perspective of data security, immutability, blockchain is good. I hope.
Yes, sir.
That is-
Got it. Absolutely correct. Thank you, sir.
Yeah. Okay.
Good evening, sir.
Yeah.
Is like IDS and IPS system will be work over there?
Idea.
Intrusion detection and prevention system?
Sir, you are not audible.
I think sir is not audible. What was the question?
Yeah, sorry, I lost my connection. Yeah,
I thought you were
Uh,
asked about IP or something.
yeah, you were asking about IDS. Shima, you were answering. Then,
No. Since you were blocked, I thought to answer. I didn't understand the
oh,
question. IDS or IPS?
can you? That is, I didn't understand the context in which you actually asked that question. Can you clarify whether IDS or IPS will work in?
So regarding the prevention in that perspective.
Regarding the privacy or regarding the security?
Yes, yes.
Okay. In the privacy space, intrusion helps, but not the way we are trying to solve the problem. Like we were trying to protect the data by making it anonymous or with DP like that. But IDS is trying to solve similar problem, but in a different way. But again, I would come back to my base point. If you are over the internet, or if your data is out there, like in the sense like is in digital form, don't expect 100% privacy. The best you can hope for is make it difficult or make it too costly to get to your actual data. But I hope I have answered your question.
Yes, sir. Thank you.
Okay, thank you. I would also say that there is an interesting thought from a few think tanks out there. Within the next 10 to 15 years, the cloud will burst, meaning all the data, everything that you have stored in cloud. Again, I have no literature to actually back this up. I've read a few reports from a few think tanks stating that the cloud will burst, meaning all your data that is actually out there in the cloud, it will be available in the open domain. It is just a views from a couple of think tanks, so I'm just putting it out there. Yes. Any other questions?
Yes, sir. Sir, I heard that you are dealing with smart home privacy system also. So my research is I am trying to improve the privacy and security concern challenge of out using blockchain. Which you say that now that blockchain cannot secure, it just simply helps to protect the data only. Okay, so that data does not get manipulated. So can't we use the smart contracts to write such kind of code that will protect it from or combining this ABAC and RBAC to give a better access control mechanism?
Yes, as far as access control is concerned, yes, smart contracts do help. They will significantly improve, or it will help you to solve the problem what you're trying to do. But from a practical perspective, the cost. At what cost? How much are you willing to, or what is your computational challenge you are going to face? Or how expensive it is going to be? That would be your other side of the argument.
Yeah, the performance degrade, that is something that I have seen. One thing is that, and the smart home providers are going to spend the money to make it secure, but yeah, the performance will decrease, the latency increases, the response increases.
Latency then with smart contracts, unless and until maybe Shima can take this. She's working on smart contracts also. Shima, any thoughts?
Yeah, actually, we have worked on imbibing differential privacy with smart contracts. It's an area of research that we were working with. As Sir said, transactions and valid IDs. Valid IDs are actually pseudo-anonymized. It's not completely anonymized. And there is something known as ping pong. If you have read through blockchain, so in that ping pong transaction kind of a thing, there are chances that our private information are leaked. So our area of work was on that, and we did come up with a solution too. But practically, we need to check on how the gas cost would be, because blockchain has a tremendous amount of gas cost that is to be. So whenever we are incorporating privacy mechanisms into it, because there is a very fine line between security and privacy. Security is wherein you are protecting against unauthorized access. However, privacy is defining the ability to protect personally identifiable information. So, if the problem is to protect personally identifiable information, yes, we can in smart contract we can code in a way that a noise is added to our personally identifiable information, but the challenge is trade off with the gas cost.
Yeah, I would further add by saying that there is a popular view out there that in the future, uh, smart contracts will dominate, meaning because of its uh, less probability for corruption property. Uh, all your future, no, I would say transactions, the things that we do or the services that we actually get. That is, there is also another white paper from another think tank that is out there, stating the same, saying that smart contracts will basically dominate the services that you actually get because of its fairness. That is, there is no manipulation there, and things will be put on the chain, your government services or your all such things. There is that school of thought is actually also out there. But to answer your question specifically to homes, it depends on the cost as far as the practical implementation is concerned.
Uh, so cost as it means the Ethereum cost you're talking about, because we can implement a private blockchain complete. We can create a
uh,
complete private blockchain, correct?
yes, you can do
Like
that. The cost
like
of doing that.
yeah, just an example, like Philips would be having their own smart home kind of system,
Ah,
and any Schneider would have their own kind of smart
ah,
home. I
ah.
mean, so they will have their own private blockchain. So
True,
that is my question. So
true,
only
true,
the
true.
customers of Philips are
Yeah,
going to have. So they
yeah.
can also add cryptocurrencies
Ah,
or some kind of tokens. So those
ah.
who have token can only use those
Can
smart
only
home.
enter it. Yes, true.
Yeah.
That is the whole base of your NFT kind of thing. No, that
Eh,
is.
eh,
If you
Yes.
want to enter my home, you should have this NFT kind of thing. Yes.
Yeah, correct. Use
Yeah,
a token kind of thing, and
yeah,
token would
yeah,
be available with the same
yeah,
company
yeah,
buyers.
yeah. So finally, some practical application for yeah, yes, you would be right there. Yes, like you are right. Any other
Okay.
questions?
No, thank you very much, sir.
Yeah,
Thank you very much.
yeah. Thank you, thank you.
Thank you, madam.
Yeah.
Any questions? Okay, let's conclude. Good evening, everyone. On behalf of the Department of Computer Applications, MES College, Marmbali, I extend my heartfelt gratitude to our distinguished speakers of today's session, Dr. Arun Cyril Jose, Assistant Professor, IIIT Kottayam, and Ms. Shima Madhusudanan, Client Delivery Head, Prevalent Cochin, for their insightful talk on privacy preservation tools, working of Tor browser and security. Dr. Arun sir explained in depth the working of the Tor browser, highlighting how it plays a vital role in ensuring anonymity and protecting online privacy. His clear explanation helped us understand how Tor addresses some of the key challenges of digital security. Ms. Shima ma'am added practical value to the session by introducing useful privacy tools such as Proton VPN, Privacy Badger, etc., which showed us simple and powerful ways to safeguard our online presence. Her talk made the concept of privacy preservation more approachable and relevant in our daily digital lives. We sincerely thank both speakers for their valuable contribution, and we believe the knowledge shared today will inspire the participants to adopt safe and secure online practices. With this, we conclude today's first session with sincere thanks and hope for a safer digital tomorrow. Let's go for a short break and we will rejoin within 5 minutes. Thank you all.
Yeah. Thank you.
Thank you.
Hope I'm audible.
Yes.
Thank you. Hope you all had a short break. Is everyone back with us? I hope so. Shall we move on to the next session? Welcome, dear participants. As you all know, we are now on the 4th day of our adult faculty development program on securing the future, cybersecurity, forensics, and the world of blockchain, organized by the Department of Computer Application, MES College Marambally. Let's move ahead with the second session of day 4, which promises to be another insightful and enriching experience for all of us. It is my privilege to introduce our distinguished resource person, Dr. Mahalingam PR. He currently serves as Senior Manager, Pre-Sales at INAP Information Technologies Private Limited, and holds a PhD in Machine Learning from VIT Vellore. An alumni of Rajagiri School of Engineering and Technology, Kerala, he earned the second rank in his MTech journey. He has also contributed his expertise as a faculty member at Muthoot Institute of Technology and Science, Kerala. Dr. Mahalingam has an impressive professional profile with 14 certifications across leading technologies such as AWS, GCP, Azure, Oracle Cloud, GitLab, and Kubernetes, along with around 25 publications in machine learning, system programming, networking, and cybersecurity. He is also an active member of professional bodies, including IEEE, ACM, CSI, ACCS, and CSTA. From my experience working with him, Dr. Mahalingam demonstrates extensive knowledge across domains, notably in cloud security. Today, we are fortunate to have him with us to share his insights on a highly relevant topic, application security in cloud. With great pleasure and warmth, let us welcome Dr. Mahalingam PR. Over to you, sir.
Thank you, Bismi ma'am. As she mentioned, I had the fortune of working with her during my stint at Muthoot. And as always, thank you for the warm welcome. I'll keep my video off for sake of bandwidth preservation because I don't want to overwhelm anyone's bandwidth by turning my video on as well. So, sharing my screen now. Hope you can all see it.
Yes, sir.
Thank you. So I promise that this will be a slightly shorter session for the reason being some of these are already known to many of you. But the other thing I would like to promise everyone is that this is going to be a session wherein you will contribute as much as me, because I will be giving some small challenges to all of you, which you can just think and respond during the session, so that I don't want to keep this a monotonous exercise. Without spending any more time, let's get started with application security in clouds. So it's a topic that has been gaining, it has gained a lot in the past couple of years, but it's steadily gaining traction across domains, across implementations, across verticals. For the reason being, post COVID, we are all relying on a lot of cloud services. And any vulnerability in the cloud is going to be a bit dangerous because we are depending a lot on it. But let's start with the session in general. So I'll just give you a quick run through the objectives of the session. So by the end of this, you will be able to kind of understand the unique security challenges in cloud application development, because most of us have done something on cloud security. So we may have done some forensics, we may have done some analysis a lot, but there are certain things which cloud throw into the mix at that point. Then there is something called as a shared responsibility model, which we all have to be aware of, especially when we work with the cloud. Then identify some common cloud vulnerabilities. So that's going to be a place where you will also help me with identifying some things. Then some security best practices, which we will discuss upon, and probably some real world security incidents along the way. So we may feel that it's a loaded agenda, but trust me, it is a simple one, and it is something which we all have to be aware of as we move on. Right. So we all have a lot of exposure to applications in general, right? So we all use operating systems. We are using Google Meet. These are all applications. They are typically native applications. That is things which run on your device. But at the same time, they are also cloud native applications. That is, there is a cloud element involved wherein the cloud runs the show as far as these applications are concerned. So when we say native, we typically mean applications that just run on your device, typically your word processing engines, your spreadsheets. All of these are mostly native, even though nowadays there is a cloud element involved, but they are mostly native. But anything that runs on the cloud and provides a service or is a good component or good share of that application, they are typically called cloud native because they are designed for the cloud. They are designed to run on the cloud. And that's one of the reasons you will not find a Google Meet that runs within a LAN network. You need internet to run Google Meet because it's a cloud native application. It's supposed to run on the cloud. So statistics say that 94% of enterprises nowadays use cloud services. It's last year's number. So this year the survey is just going on. So 94 is a big number. So as I said, especially after COVID and all stuck, what happened was we were all in our places of residence most of the time. So how did we connect to each other? How did we get our work done? We use the internet as the backbone of that. And that is when a good share of the companies or organizations or enterprises started adopting cloud. Right? And the average organization uses 10,000 plus cloud applications. That may look like an exaggeration, but there are organizations, especially in software development, that run thousands of cloud applications, small or big. There is some cloud involvement with that. And since we have these many cloud applications, people spend a lot to keep that secure. So $13.9 billion is the security spent on cloud globally. Even then we are facing problems. So we will see some of the problems later, but even then we are facing problems. And the reason is we think from a traditional security mindset. So we think just from the point of view of logins or maybe some security or some network based. But there are certain additional things which we need to consider in the cloud, which people don't think initially. So that is where there should be a mindset change if we want to implement security on the cloud, especially in today's landscape. Okay. So that is what we are going to have over the next probably 60 minutes or 70 minutes. So before we even start, so you all are part of either the faculty community or probably student community or even industry. So can you just tell me how many cloud applications does your institution or organization in general currently use? Or can you just give me a list of applications that you use which are cloud-based? Can somebody, you can put it on the chat, that is perfectly fine. I can read the chat. Or you can talk, anything is fine.
Like LMS tools, sir, we are using like Camo.
Yes, LMS tools, that's an excellent answer. LMS is typically run on the cloud nowadays. Yes. Anything else?
I think HR apps also, HR apps in some of the universities.
Yes, HR apps. Even if the HR app doesn't directly talk about cloud, their compute data models may sometimes be on the cloud. Most of these applications either run on AWS or Azure. That is more than enough. They are cloud-based applications then. So whatever you said is right. Almost 99% of these applications are cloud-based. Anything else?
Means like we are using Google Drives. These are all
Yes, absolutely. That is the widest one across institutions and organizations. Things like Gmail or Google Workspace or Microsoft Workspaces, they are all cloud-based. The Gmail we use, the Google Drive we use, the G Docs, G Meet, which we are working on right now, the slide I'm sharing via Google Slides, these are all cloud-based applications. And as you rightly mentioned, our HR apps, LMS. So these are all cloud-based. And even let me give you even closer example for those who are under the Kerala Technological University, the entire e-governance platform. They all have at least one component running on the cloud. So that is closer than we think. We use a lot of cloud applications, whether we know it or not. And that is what makes this very, very interesting. So anyone else have any software to add? Google Drive, Zoom, yes. Digital Workspace, WebEx, Moodle, yes, these are all. At least Moodle sometimes is installed locally, but even nowadays 90% plus is running on the cloud. Very good. Quite a lot. Okay. So now we all know to what extent we use this thing. So when we run things on the cloud, so I'm not talking from the user perspective, is again one additional layer, but when we run things on the cloud, security of that particular thing is based on what we call as a shared responsibility model. Okay. So the reason this was originally formally documented by AWS, and the reason they had to come up with such a document is that people will just put something on the cloud and assume that it is safe automatically. And whenever some problem happens, they will just go and blame AWS, saying that it's your problem. So that is when AWS came up with a formal document which talks about what is called as a shared responsibility model. So what they say is the security of your particular application is not just our responsibility, it's equally your responsibility. Okay. So in other words, they divide the responsibility into two pieces. One is the cloud provider's responsibility itself, which is security of the cloud, for which only they can be responsible because only they have access to that thing. And there is an equally customer responsibilities, which is security in the cloud. That is more towards the application we are building. So what is the difference between those? So what AWS is responsible for is physical security of data centers. For example, it should make sure that somebody doesn't just break into the data center physically and take something from there. That only AWS can assure, or Azure or GCP, somebody, only they can do that. Hardware and network infrastructure. So the actual installation is their responsibility. The hypervisors, host operating system, they are responsible for the security of Ubuntu or the Linux versions or Windows versions that run on their cloud. For that, they are the only people who can be responsible. Service availabilities, make sure that the application is available all the time. That is their job. Compliances is their job, because only they can be compliant to some regulatory standards unless our application has specific things. So the cloud provider will ensure that whatever they are giving you is secure. And then whatever you build on top of that is your responsibility. That is the identity access management. That is the logins, how secure the login is handled. So all that is the application builder's responsibility or the customer's responsibility. Application level controls. I cannot just open a database to the internet and say that AWS will take care of the security. It won't, because you exposed it. So that's a customer's responsibility. The OS updates and configuration is again our job, unless we are just using their SaaS platform. Network traffic protection is again our job. If I don't use HTTPS, don't expect cloud to just come back and secure that thing. That is again us. Then data encryptions, classification, everything is our job. Even though cloud encrypts at rest, we should tell cloud that you should encrypt it. And if I just create a normal file and put it in the drive and say that nobody will be able to read it, that's nonsense, because anyone can read it if you are not securing it. So what shared responsibility model says is, unless you build your applications properly, cloud will not be able to secure it for you. So this is a diagrammatic representation of what happens there. So AWS is responsible for the hardware and the cloud software. The customer is responsible for the customer's data, all the access management, the operating systems updates, network configurations. So note that it's configuration. AWS handles the network, but unless we configure it to be safe, it won't. Then client-side data, all those things are our responsibility. So now the question becomes, how do we ensure the blue part, that is the customer's part of the responsibility? And why is this differentiation important for people who develop these applications? So that is the crux of what we are going to discuss in this session, which is on security in the cloud. Okay. So before I even talk about any theory or practice in that, so let's see. So this is problem one, is an activity for you all. Okay. Now the question is, who is responsible for these things? So assume everything is on the cloud. The first one is a denial of service, a distributed DDoS attack brings down a web application. So who is responsible for ensuring this doesn't happen?
I think service provider.
It's a service provider, absolutely. And if you have enabled DDoS protection, absolutely, the service provider should be responsible for doing that. Perfect. The second scenario, unencrypted sensitive data stored in a database. For example, I have a password, a username password. I just stored the password directly in my database. Who is responsible for securing, to maintain the security of that thing?
User, sir.
The user has to do that. Perfect. A developer accidentally exposes API keys in GitHub. Obviously, it's a developer's problem. Nobody is supposed to check in API keys. The cloud provider central data center loses power.
Service provider.
Obviously, a service provider, because it's their problem. Malware infects a virtual machine.
User.
Is it user or is it the provider?
No, provider.
User.
It's actually both. It's actually both. The provider should ensure that there is an anti-malware installed. It's a virtual machine, that's why I asked. Okay. But if the virtual machine was built by the user from scratch, only the user can be responsible for this. But if the VM was given by the provider is equally responsible. So that's the difference. Weak passwords allow unauthorized database access. Obviously the user, because password is set by the user. Seventh one, it's a very practical problem. Your computation and data are in the same subnet, causing leaks via public IP. So your computation is exposed via public IP, your data is also in the same subnet. Who is responsible? It is a
user only.
It's a user, right answer. So it is the user's responsibility because they designed it like that. It's a design problem, and the cloud has nothing to do with that. So there are certain problems which the user is responsible for, certain things which the provider is responsible for. So a typical example of a cloud specific problem is item number 7. When we build native applications, we don't care about where compute and data is most of the time. It's sitting on our device. The moment you put it on the cloud, you need to make sure what subnet is in and what access the subnet has. So somebody who gains unauthorized access to one subnet should not go to the other. So all these should be ensured as part of your design. So these are things which we quickly overlook, but these are things which we need to take care of. And that's why cloud security is a little bit more specific compared to the regular application security. So how does the security landscape look like nowadays? So typically, if we look at the OWASP threat list, top 5 are injection flaws. SQL injection is something familiar to many of us. We will have a search bar and we put an SQL query, it returns an answer, which is not supposed to happen. So SQL injection is a very typical example. That is still, ironically, that is still the most prevalent security threat, despite that being on the top for at least a decade. It is still the top one because people haven't patched it properly even now. Okay. Second one is broken authentication. We may think it's just weak passwords. That's not the thing. I will show you an example. Okay. So I'm just going to switch to another window here. So typically when we have these authentications, username, password authentications, we have what is called as a JWT, a JSON Web Token. That's typically done by all applications, including the likes of Gmail and all. But the problem is, not everyone takes care of what is sent as part of the JWT token. For example, I'm just pasting a huge token here. Look at the kind of information it has. So thanks to one of my colleagues for putting this example together, because this was done as part of a simulated attack last time on one of our applications. Thankfully, it closed it, but look at the kind of information a single JWT token could potentially have. A hash value, an AWS sub value, an email verification status, the endpoint to which this validation is going to go, the Cognito username, the user ID of that user, an event ID for identifying this, a token use, what kind of ID it is, when it is authenticated, what tenant ID this person is for, what's the family name of the person, what's the email. Depending on how we configure a JWT, this can have all this information. Look at the claims it's generating. Very long set of claims. So this is equally a problem. Okay. So even if I have an extremely strong password that is 200 characters long, if I am putting everything into a JWT token, that is going to be a big issue. And here is another one. This is the access token for that. An event ID, what token it is for, what is the scope? It's a sign-in. When it is authenticated, when it is expiring, JTI. Actually, somebody who has access to all of these can use the parameters here to simply hijack my session and go. So that is how weak an authentication system can be. It depends on what kind of data you expose as part of authentication, especially if you are having a Gmail based authentication. If you don't handle it properly, your entire Gmail credential is just going to go. And that is the reason many people insist on what is called as a multi-factor authentication. Even if you get this, unless you have an MFA configured, you won't get the actual authentication. So that's the benefit of that. Then sensitive data exposure. For example, the example I quoted just before. if you have a password and you just store it in the same way in your database, if somebody gains access to it, they will just go and read it. Simple. And misconfigured cloud storage buckets is one part of that. I'll show you yet another example. So in cloud, we have this thing called buckets. So that is where we store files. And here I'm just going to search for a couple of keywords. So this is a website called osint.sh where we can search for public buckets. So every cloud service can either be can either expose buckets or we can keep it private. But there is, when I search for two keywords, one keyword being SRC, which stands for some applications source code is there in a bucket, that's perfectly fine. And I gave an extension called env, which stands for environment file. And it picked up one bucket. Thankfully, it is not existing now. But there was a bucket at least 30 minutes ago, which had an env file exposed as part of it. So there's a DigitalOcean space, so the bucket name would have changed by now. But there was a bucket 30 minutes ago. And that env could actually have some passwords, which was hard-coded into the environment file. So that is also sometimes accidentally placed on a public cloud. So that's will not happen. So sensitive data exposure is a very important problem. Insufficient logging and monitoring. So tomorrow somebody does a DDoS. People come to know about that 1 hour later. Nobody knows what happened because there is no logging. Nobody knows where that thing came from. Nobody knows how long it was. Nobody knows what payload it was because nobody logged anything. So as much as threat prevention is important, threat analysis is also important. So logging and monitoring is a big mistake people do. They don't do that. And security misconfigurations. I'll give you a very simple example. Many of us have used the Oracle database as part of academics, right? We all teach database systems. What is the default username and password for an Oracle installation?
Scott Tiger.
Scott and Tiger. Exactly. So somebody accidentally exposes their Oracle instance onto the internet, and if they haven't changed the default password and username, what happens? Anybody can log in with Scott and Tiger and take their data. I can run a query, select it, select star from table set, select describe tables, get the schema, select star, do anything with that default credentials. Never do that. And there are services for whom the default username is root and the default password is blank. And unless we change it, anybody can log in from the internet into those services. That is so these configurations are also equally important. So if you look at cloud services or cloud security in general, these are just 5 top problems. There are at least 50 problems down there which just bubbled up. But something common across all of these is these are all the users' problems. It's because we designed the application wrong. It's not about the cloud provider not doing their job properly. So let's look at a case study. So if I have marked anything in blue, it means it is a point for discussion wherein I would like your inputs. So this is a case study for the Capital One insurance breach. It's one of the largest financial data breaches in recorded history with 100 million customers affected because of the breach. Somebody took all their financial records from AWS. And what happened was they didn't configure the firewall properly. There was one role who had read access to every table in the database. There were some S3 buckets that were just kept unsecured and sensitive data were not secured properly. So now let's look at the responsibility of these. Which parts of the responsibility model failed? Was it the customer? Was it the cloud which failed? And it's obvious that the customer failed for the simple reason that whatever happened there was because of improper handling. Yeah. Now, what could have prevented this breach? That's the answer I want. How could they have avoided this? You can either tell me or you can put in the chat, either is fine. What could have prevented this? So there are 4 reasons that have been identified, that have been mentioned there. What could have simply prevented this thing? And 2 and 3, the questions 2 and 3 go together. How do you redesign the architecture of that? Give a proper IAM role. That's a nice answer. That's the right answer. One of the right answers, absolutely. So let's look at the reasons one by one. A misconfigured web application firewall. The fix is very simple. Do it properly. Set the alerts properly. And when we set up web application firewalls, we can actually limit it to geographies. We can limit it to type of users. There are a lot of things we can do on WAF. Do all that. For an application that handles financial data, a web application firewall is mandatory. Second one, an overprivileged IAM role. Don't give IAM roles read access to everything. The key lesson number 2, the principle of least privilege is critical. So suppose there is one function that needs read access to a user table, give it only access to the user table. Don't give it read access or write access or anything to 20 other tables in that particular database. Least privilege is of importance. Okay. Then S3 buckets. Secure S3 buckets is just one tick which they need to give during configuration and it will be secure, which people don't do all the time. Sensitive data exfiltration, whatever data you store, don't store sensitive data as such. Secure it, encrypt it when you store. So reconfiguring the network, the firewall, the encryptions, do all that and your thing is done. So the key lessons are configuration errors are the number 1 cloud security risk. All these are configuration problems. Most of these are configuration problems. A misconfigured WAF is exactly a configuration issue. IAM role privilege is a configuration problem. S3 bucket public is a configuration problem. So these are all configuration issues. Very simple things that could have been done on day 1 didn't happen and it just went on. Principle of least privilege is critical. So only give access to what it wants and not access to whatever there is. It's a need-based access. And the third one is continuous monitoring is required. Keep checking. Probably set an alert for every 5 seconds or 10 seconds or 20 seconds if needed for very critical applications. Okay, the attack should not go on happening. And they fixed it. They fixed it in a day. But 100 million customers data, it was there on the dark web for years. And every customer had to go in and change their password within the next 24 hours. So that is one typical case study. It's one of the largest financial breaches recorded. So now we saw a person fail. Now let's look at how we can actually do the cloud native security architecture. Okay. So the first use case I'm going to look at is many of us use Docker. Right? Docker is nowadays used very commonly. So when you have Docker, make sure that your image is from a trusted source. You do it on proper sandboxes. Don't store your secrets, I mean in the usernames, passwords, etc. within the container. You store it outside. network policies. All these are very, very important things for container and serverless security. Okay. Even for serverless, just give bare minimum permissions. Event source validation is something nowadays we all use. That is, if a function call comes or an API request comes, check from where it came. Unless it is from a validated source, don't even accept that request. Okay. Then dependencies, all those things. Then container security, use very simple base images, don't overload it. At the same time, make sure you add the patches as required. So there are a lot of things which we do for container and serverless security, for the reason that these two are the most popular nowadays. Okay. So now this is an activity for us. Your university is migrating its student information system to the cloud. So there's a web portal for students, an admin dashboard, a mobile application, external services. For example, it could be payments, it could be an attendance system, it could be an HR system, something. And there is a database with sensitive student records. Their name, their Aadhaar number, their date of birth, username, password, marks, quite a lot of sensitive information. So now the task is, how will you implement the shared responsibility model? What security controls will we add? How do you handle data encryption? What monitoring and login will we implement? So now let's take things one by one. What about the web portal for students? How will we secure the web portal for students? Can anyone give some ideas?
Means after creation of the website, same sir, it should be tested for the different attacks. It may be SQL injection or penetration testing. That's what nowadays they are doing, bug bounty or something.
Yes. Excellent. Test it properly. Very good. Something many people don't do. Test it properly. Perfect. Then, what else? How do you actually secure that? So testing uncovers all that. Data encryption. So how do you handle the data encryption? So there is a very simple solution, not solution per se, a simple way in which we add a layer of security. Unique passwords. Yes. The password should contain one capital number, one capital letter, one small letter, 3 digits, 2 special characters, should not contain the year of birth, should not contain date of birth, 20 other rules. Extremely complex password. Yes, that's one thing. And along with that, I will do one thing. I will enable multi-factor authentication. An OTP comes to your phone and only then you can log in. That's also a possibility. Then anything else you can do to secure that application in total? Just recollect what we talked about in the previous slide. What are the key takeaways? Misconfiguration is the biggest problem. So what do you configure properly here? Security encryption, password, locks. Yes. First of all, make sure your firewall is properly configured. We have a database with student records. Your firewall should be really good. That's the first one. Then, subnets data should always be stored separately with very minimal access. Anything else? HTTPS is one of the first things you need to ensure if you're handling critical data. Configure your CDN or your endpoint to make sure it uses HTTPS. So these are all simple methods by which we can secure our architecture. And what monitoring and logging? You generate reports every hour, number of requests, number of responses, the source from which the request came, the kind of request that came in, all those can be monitored across. Okay. So the consensus is clear. Everyone wants to make sure that there is proper data encryption, proper passwords, proper access control. That's good. So this is yet another example. This is a very interesting example because somebody actually used Docker Hub to put an image that contained a cryptocurrency mining algorithm. Or in other words, there were thousands of people doing cryptocurrency mining for that person, free of cost, because nobody knew there was cryptocurrency mining happening in their own images. Big problem. And the reason is that guy took a legitimate container image, modified it to add the mining algorithm and just kept it running. And how do you detect this? Because we only get an image. How do you? Yeah, so sorry, I just saw the response from Rijo Matthew. Yeah, that's a good one. Really good response from Rijo for the previous one. DLP tools, data loss protection tools, is something by which we can secure the platform. Tokenizations, yes. Multi-factor authentication, role-based access control, very good. That means only those roles who are permitted to do something need to do it. Otherwise, don't do that. Yeah. So in the case of coming back to the cryptocurrency mining attack, so how could an organization have detected this problem? So suppose tomorrow, I'm sending a Docker image to everyone saying that this is a new application I have built. Just keep running it; it will do wonders for you. So how do somebody detect whether something malicious is going on in that? This is a cryptocurrency mining attack. So there's a very specific thing that happens in cryptocurrency mining. Can anyone tell me what? There's something very, very typical of a cryptocurrency mining attack. Can anyone guess what it is? Cryptocurrency mining eats your CPU. It will consume a lot of CPU percentage. Unnaturally high CPU percentage for the particular container means there's a good chance if there's malicious code running in that. Unnaturally high. For example, I am giving you a container for a website, and if it is taking up 100% CPU, a website should never take up 100% of your CPU. It should take 30 or 40% maximum. If it is 100, there is something happening in the background. Go and check. So that is part of the monitoring. So what is actually running in your device or your network is something you should be aware of. And not just that, this container will actually be, GPU as well. Absolutely. It could affect GPU if your container is configured to use GPU or CUDA to run. It could. I'm not guaranteeing it will, but for containers which is configured to use CUDA, it could hit the GPU also. So that's a possibility. And secondly, this thing will send updates to its chain. So that is something the network level we can detect. Is there a consistent set of updates going to a particular chain consistently or periodically? That's something which we can also analyze. So the CPU and network activity should be able to detect things like this. So that is why when we are running anything on the cloud, make sure that there is proper monitoring as well. What is happening in the cloud is something we need to be always aware of. So this is something which we talked about here and there. So I'm not spending time on this slide, but when I share the slide with you, you can surely go through that. So some of it just talks about how the security happens. So whenever you have a third-party integration, make sure the authentication is not broken. You don't expose way too much data through these things. And rate limiting to avoid DDoS, and proper asset management. Are you actually using the right APIs? All these should be properly kept track of. And that brings us to the third case study. So whatever I said just before, we can explain it as part of this. How many of you remember the Cambridge Analytica scandal? How many of you heard of that? This happened a few years back, but does anyone remember what happened there? It was a Facebook related issue. Cambridge Analytica used Facebook APIs to read data of every registered user in the US. And it used this data to create a prediction model to predict who will win the next presidential elections. Cambridge Analytica actually was taken to court for breach of privacy because of this. And along with that, Facebook also got penalized because it was Facebook's API they used. It was an analytics company, it was an analytics platform which tried to predict the next president. They did a good job of that. But then how they did that is by scraping user data from Facebook. 87 million users' data was used, including their political affiliations, the kind of content they post. Are they pro-Republican, pro-democratic from their content? Everything was picked from Facebook. And they did a full analytics on that. And the vulnerability, what that happened was Facebook actually allowed the API to access every last bit of information from that Facebook account holder, which was not supposed to happen, but the API was so permissive that it was doing that. And before that period, Facebook didn't allow us to lock our profiles. Nowadays, many of us have profile locks, wherein we can decide what a third person can see. That was not there earlier. Earlier, everything was a profile. So now they had to implement a data access part of that. There was no audit trail. Nobody actually knew that this data siphoning was happening. All they knew was this API was being read. Nobody knew what data was going. So there was no proper audit trail. And third-party app was not vetted properly because people could just add Cambridge Analytica to their profile and starts doing things. Nobody knew or nobody checked what happened. So the solution for that is a proper design for authentication and authorization. That is the app actually authorized to read your data? These are all things nowadays people check for. Limit your data access only for essentials. For example, Cambridge Analytica can read your name and probably location, not even location, name. It should not be able to read anything more than that. So data access limitations are something which is very strict for any third-party API nowadays. And third-party integrations are now extremely scrutinized. So this is yet another real-world use case of what happened when things just went rogue. So that's because, again, of a configuration problem. A third-party service used Facebook APIs or a specific API that had too much permissions and took data of 87 million people. Not just data, including the wall post, including the fronts graph, everything. So that's equally a problem. So how do people fix these things? So DevOps has been a practice for a long time now, but now we are talking about DevSecOps, develop, secure, operate, or development, security, operations, wherein a common team actually sits together, develop something, evaluate the security, and then deploy for operations together. So what they typically do is they evaluate the security of all of these. So whenever, if I am building a software for myself or for somebody else, nowadays, security is part of every step of the process. For example, we can actually automate the whole cloud process by building what is called as infrastructure as code. We can write a program which will just control the entire infrastructure in the cloud. It is always scanned for security nowadays. For example, is there anything like an unwanted permission or unwanted access which should not be there? These are all scanned nowadays. Policy as code. Policies are now hard written as code as part of IACs. Access policies, like which can access what, how many people can access something at the same time, what is a cool-off period, which region can access something, is VPN allowed? All these are policies that they are now hard-coded as code. And compliance, there are a lot of rules nowadays through which all these code blocks go and get evaluated. So that is there. And there are different levels of gates. For example, the first level itself, we have source code analysis. So whatever programs we write, there should be an application security test. What is it reading? How much data is it reading? Is it reading too much data, which is eventually getting discarded? All these are measured. Software composition analysis. Is it using any malware or a possible malware? Is it exposing anything which it's not supposed to do? So all these are then evaluated. Secrets. Are there any usernames or passwords or port numbers that are just getting exposed as part of the software? All these are evaluated first in the source code level itself. And once the source code is found to be secure, then the next step is you build the code, compile it, and then you check for the whole image. Is there any vulnerability in that? Is there any dependencies that are causing vulnerabilities? For example, is my program going to require a Windows 95 installation? Am I using a library that only runs on Windows 98? If that's the case, these things are all extremely outdated. They are all vulnerable. Don't do that. And are there any licenses? For example, an application handling credit card data needs to have a compliance called PCI DSS. A medical data application needs a GDPR, HIPAA, lots of compliances and licenses have to be implemented. These are all supposed to be checked. And after deployment, you start testing the actual application. As well, we heard a few slides back, do a comprehensive security test, do a comprehensive penetration test, do tests for SQL injection, do all that. That's dynamic application security. Try to create 20,000 users together. What happens? So these are all things which we do. And we also check for infrastructure configurations as part of that. Try to send 1 million requests together. Does the firewall just block it or does just let it go? These are all things which we test over there after deployment. So 3 levels at which we do the testing nowadays. The source code is first checked for testing for any problems. After building, it checks for dependencies to see if there is any problem. And after that, even after this thing goes live, we keep testing it and always keep monitoring for any problems. And now it's a problem session 2, incident response planning. So now you have a cloud-based learning management system, which we deployed previously. And now there is a problem. After this thing went live, somebody had unauthorized access to student data, some potential data got lost or read. The performance just went down. People are now talking all about this, saying that University X has a very bad data management thing. All students' data got leaked and things. Now, what you have to do is, how do we handle this? So there are 3 levels in which we handle these cybersecurity threats. One is the immediate response. It's called an IDR, incident detection and response. Detection is anyway done. Incident response is what is a problem. So there is an immediate response that is required, a short term and a long term. So now let's do this one by one. So what is immediate response? So suppose you found out that this happened. You are handling the entire infrastructure for that application, and you suddenly saw that this happened. How do you respond immediately? Yes. How do you respond? So your application now has a problem which people are beginning to alert. Student records are going out. System is slow.
By
It's
notifying,
now the huh?
notifying to the provider.
No, you are the provider. Assume you are the provider. What do you do?
Stakeholder information, stakeholder notification.
Stakeholder notification, exactly. So how do you do that? You send an email or you call up all your customers and say, there is a problem, we are shutting it down. That should happen within the first 1 hour. That is most important. So that takes 3 steps. Detection, obviously we are doing it. Alerting. So there is an alert saying that there is a data loss. Initial containment means you immediately shut the system down temporarily. Don't let any further data go. Whatever is gone is gone. You can't do anything about that, but at least let the rest of that thing don't go. And then you tell your customers, for example, your university has 20 colleges under that. We call all 20 of them and say that there is a problem. We are shutting down the system temporarily. That is the first thing, the immediate response. So you are limiting your damage now. Second phase, short-term response. Now, how do you do that? So you need to do a detailed investigation, find the evidence, and then how do you let others know about that investigation? So the problem we identified was unauthorized access to student data, potential data exfiltration, some performance issues, and the fourth one is not a software problem. So that what could be the reasons for the first 3 problems? What could be the reason for some data getting exposed?
Firewall problem, sir.
Huh?
Firewall.
Firewall problem, yes. Firewall was not done properly. Then anything else that could be a problem?
Some malicious code is
Malicious code properly,
because of
and somebody hit an SQL injected malicious code or XSS script the malicious code. Anything can happen. Then any other problem?
Root cause analysis.
Yeah, RC will do that, but what could be the reason? So there are a few problems which we already talked about. Yeah, malicious code is a problem, firewall is a problem. Then anything else that could cause this? How did that data get exposed in this place? Database was not secured properly, so that is the problem. And then system performance degradation. System is running slowly. It could be a probability DDoS, distributed driver service, which is causing performance issues. So investigation is done into each of this within the next 24 hours. So you need to evaluate system logs, and you need to sift through the access logs. So all of these have to be done, and you preserve the evidence. You need to record that over the past 1 hour, the 1 hour prior to that incident, there were 200,000 requests that went into it simultaneously. There was one user called ABC who logged in, and that API actually got access to the entire database. So all these evidences should be tracked. And whatever communication you send across should be detailed enough to say that this is the problem. And then the long-term response. Long-term response is where you do the root cause analysis. So then you dive further. Why did the DDoS attack go through? Why didn't the firewall just block after the first 1,000 requests? Is it a problem with the firewall configuration? Is it a problem with the access rules configuration? Is it a problem that 20 different IPs were used? What was the problem? Why didn't it block? Secondly, why did user ABC get access to the entire data? Was there any SQL injection they used? Was there any unauthorized payload in that API? Did that API actually come from a web browser, or did they use a terminal to run that? All that RCA will start getting run. And then you harden it, like you fix. You modify the configurations, you set the locations, you reduce the scope for APIs, you use MFA, all that. And then you also integrate all the lessons learned. So it's an elaborate process. Okay, so you can imagine what kind of work the people in Cambridge Analytica or Facebook or Capital One did when that incident occurred. So if you look at what Capital One did, the immediate response was they got the alert. They immediately sent an email to all their customers saying that there is a breach. We are taking down the platform temporarily. And then within the next 24 hours, they investigated, found that there was a firewall issue and there was a database issue. They kept the data. And then the next communication that went was, we do apologize for the problem. We accept that 100 million records got leaked. There were no credit card information involved, but user credentials were leaked. So requesting everyone to change your password within the next 5 hours or 4 hours to avoid anyone logging in. That was the communication. That's a short-term response. That happens within 1 day. And then on, they went on, modified all the firewalls, did all the reworks and all. So that is how we do an incident response. Something happened, we cannot change that, but at least avoid it from happening again. And this monitoring happens in multiple levels. Your infrastructure, the application has to be kept track of, the security has to be kept track of, and there are tools which do that for you. So just make sure you use that. Okay, there are tools which keep track of that. These are some of the tools. Some of them are cloud-based, some of them are not. So if you have an infrastructure as code for cloud configuration, you can check out TFSec. They accept an IAC code and they give you a report of vulnerabilities that will come as part of that. The cloud security, AWS Security Hub, if you enable that service, it will actually do a full scan of your AWS instance and see if there are any vulnerabilities. It actually reports even the small ones, like a database port number is default or a username password has not been changed in the configuration. Everything is reported. Okay, application security. SonarQube is something which we use in industry a lot because it checks the code for any vulnerabilities and misconfigurations.
I have one doubt, sir.
Yes, sir.
This, see, we say HTTPS having 443 port and HTTP having 80 port. So
Yeah.
this means what is port? Is it physical or is it virtual?
So the second part of the question was not clear. I think there was some disturbance in the background. Can you just type it in if you don't mind, so that it's clear?
Generally, we say HTTPS having 443 port,
Yes.
HTTP is having 80 port. So what
Yes.
this is actually real? Is it physical port or real
Okay.
port?
Understood. Okay. Thank you. That's a good question. So these ports are all
Port
virtual.
means no. Generally, port means like we say USB port
Yes.
or
Yes.
it is a HDMI port.
Yes.
That no.
That's a good question. So what happens in these things is, when we look at the internet, there is only one or two ways by which the data reaches our computer. Okay. Okay, so if you have USB, you can have 4 USB ports. If many of us have HDMI ports, which is 1 port. But for the internet or data transfer, there is either a LAN port or a Wi-Fi. Right? But at the same time, when we look at port numbers, we have HTTP is 80 or 8080, HTTPS is 443. Then for MySQL, it is 3306. There are 65,535 ports out there. So these ports are all called virtual ports. Okay. So if we take a real world example for that, the physical port is like a apartment complex. Okay. So for example, Skyline Apartments, that's a physical port. So that is your Ethernet port or your Wi-Fi. Okay. Within that, you can have apartment numbers 1A, apartment 13H, or apartment number 4D. So these are all virtual. So whatever data comes from the internet, they are addressed to one of these ports. Okay. And in the other end, somebody is or some application is actually listening to these particular specific addresses. So for example, if I'm browsing the internet and probably running some program over SSH or Telnet. Telnet is port 22. Okay, so I am watching a video and running a Telnet application together. Both packets or network packets actually come through the same place. I'm using Wi-Fi, so everything will come via Wi-Fi. But how it differentiates is my videos packets will have 443 because I use YouTube HTTPS. So 443 will be the address in that or the port number in that packet. Whatever I run by Telnet, the port number will say 22. That is how it's actually virtual. So whatever comes is only going to come through my LAN port.
1 minute. Just you repeat this previous one.
Okay.
Just previous call.
Yeah, sure. So suppose the scenario is simple. I'm watching a video on YouTube. I'm running something on SSH. Okay, SSH is having a port number. By the default port number is 22, similar to Telnet. So I'm connecting to my Office server via SSH. So that is having a port number 22, and my YouTube video is playing here. Okay. So here I have 2 applications connecting to the internet because I am using my home Wi-Fi to connect to the net. So there are 2 applications running. One is running on one is running YouTube. My Chrome browser is running YouTube. YouTube is HTTPS. So that is actually saying that I am going to have house number 443 for this particular within this computer. Okay. And at the same time, I'm using my Office device connecting remotely via SSH. It will say that my house number is 22 in this computer. Okay. So my computer is the apartment block, and my YouTube is house number 443. My Office connection, remote connection, is house number 22. So what happens is, when I'm watching a video, I need data coming in from the internet, right? Google is going to send me data. So what it says, what it does is, it will send a chunk of data. It will say it has to go to port number 443. Or in other words, it is sending me a parcel addressed to house number 443. So my Chrome browser is actually keeping on listening to the entire network packets, looking at whether there is something addressed as 443 in that. Okay. So if it's 443, it will come to my YouTube, because Chrome will read it and send it to YouTube. Perfect. Not send to YouTube, send it to the tab that is running YouTube. At the same time, my remote connector is also keeping on checking the entire network packets, looking for house number 22, which is its port. So the same channel is running all packets, 443 and 22, or any port number comes through the same line, but it's addressed to these corresponding port numbers so that it understands who is going to finally use that port that packet. That is the purpose of having port numbers. Okay, so these are all virtual ports.
For students, how we can make these examples a real world example?
Sir, may I?
Yes.
See, the computer networks is based on two things. One is the postal thing, one is the telecommunication thing. The postal
Yes.
thing is everything is based is having a envelope. On envelope,
Yes.
suppose MES college is receiving data, so everything is posted on the MES. MES means our IP address. Everything is coming to our
Exactly.
phone. But to our
Exactly.
phone, whether it is coming on WhatsApp or what we say Facebook or YouTube, okay, it is like if it is addressed to Bismil, care of MES college, it will go to Bismil. To Celine, care of this thing, so it will go to Celine. So Celine and Bismil are two things which are kind of port numbers. What are these port numbers? So all the packets, their header is having a 16-bit number stored. So if that 16-bit number identifies the port number, so for that you will have to see the TDP packet header, okay, and the IP packet header. In the IP packet header it is mentioned, and in the UDP or TCP packet header it is mentioned that IP address is our source address, but on IP address to whom that, because your college there are 10 professors or 40 professors, so the professor's name is written. Similarly, on our computers, there is a port number which is given. It is 16-bit number. That's why we have 65,536 ports, okay, available. So that's the logic. So there is a port number which is predefined. You can always change a port number if you want. Okay, by default there is a predefined number which a application is there. Like HTTP is having this 8080, Surset, Telnet is and SSH is having 22 port numbers. So by default, these applications has a port number. But you are creating on your system different websites. For each website, the common port number is 8080, but you can decide the port numbers differently. Okay, so that is only the nothing but the what we write on the envelope. We write a name to whom that name is actually for whom the letter is or the message is intended. That is nothing but the port numbers. Okay, that is actually the logic of port numbers. That packet header identifies which port number the message should be received, which application that particular data should be reached, whether WhatsApp or Instagram or Facebook or YouTube.
Okay. Thank you. Yeah. Yeah. So finally, so let's just, in interest of time, we will quickly wind up these parts. So nowadays, what we just saw till now, they are all the basic cloud-based security stuff. Okay. But now things are again changing. So we have things like ransomware attacks. It's been around for a while now, but even now it's there. There are things like AI/ML poisoning attacks, making AI/ML models actually do malicious things by pre-training them with the wrong data or malicious data. Quantum computing, again, I'm not getting into a debate for that, but it is on the horizon. And there are supply chain attacks. I will, before closing, I will show you one example of a supply chain attack. Okay. So this is the Sync vulnerability database, which kind of lists everything. Okay. So very recently, not sure how many of you noticed it, people who use Node.js for developing their applications, they have a library called NPM, just like how Python has pip, Node.js has NPM, Node Package Manager. Okay. Thousands of NPM packages actually got infected this month because somebody pushed a malicious version of these very popular libraries. Okay. So somebody gained access to the NPM database and published their malicious versions. Okay. So just giving an example, HTTP server. So this is a very common one. Okay, we use this to simulate HTTP servers in Node.js. Okay. And what happened was somebody went in and published their malware version of HTTP server, and whoever users require HTTP server in their Node.js code will actually end up pulling this malicious thing. So this is called a supply chain vulnerability. That is now a very common way of injecting vulnerability into code nowadays. So what happened was whoever installed that infected version, their secret files were all exposed to the attacker. Okay. So they just ship it as part of some of these malicious packages. So, and interestingly, very popular packages were actually used. For example, Tailwind token base is something very popular. Then, and if you look at the actual repositories that got infected, a huge set of repositories from something called as CrowdStrike. CrowdStrike is one of the world's leading cybersecurity companies. So people actually don't think too much before installing something from CrowdStrike because they are a cybersec company. But in NPM, their repository got compromised and people just installed their log scale dashboards or filters or parsers. A lot of applications ended up using the malicious code. Okay. And it took actually around a few hours before people understood that this thing is malicious. Okay. So this is a typical attack vector which we are seeing nowadays, wherein people just inject malicious things into whatever people use normally and end up infecting things. So these are all different things that are happening. And especially in the cloud, these things are most important because as far as the cloud is concerned, whatever applications are using this malicious code end up exposing the data across the internet for everyone to use. So if it's a local application, you can at least just pull out the network cable and it will stop. On the cloud, there is no network cable to pull out. It is there. Okay. And cloud by design is redundant. It's highly available. So if you pull the network cable in one place, there are 5 other copies running somewhere else, which will keep the application available. So that is where cloud-specific design is required as part of all of these. And just some best practices. When you design these things, implement network segmentation properly. For service communication, it is an entirely AWS perspective. There are equivalent in all other platforms. Use VPN-based links. The firewall should be properly configured. Network data should be consistently monitored using flow logs. Then have a proper IAM. Single sign-on should be properly done. MFA, API logs. Then do proper data encryptions, protections, key management. Then DLP, data loss prevention by replication. All of these are best practices which people adhere to nowadays. And for incident response playbooks. What happened? What should be done if there is a data leak? All these things should be properly documented. Automated responses. Send an email automatically first. Quite a lot of things can be done. So there are a lot of best practices which people do nowadays to make sure that your application is designed securely for the cloud. And there will be at least 200 recommendations if you look at the full list. This is just a hand-picked few. Okay. So I won't extend further because it's already 9:15. I don't want to keep you all up. So the key takeaways from the design philosophies are: make sure you understand your responsibilities and the cloud's responsibility. Whatever you are responsible for, it's your work to get it proper. Okay. Then defense in depth, multiple layers of security. Don't just rely on a username and password to secure your whole application. Underneath that, there could be many vulnerabilities. There is no single point of failure. There should be no single point of failure. It is distributed. There are different points of failure. Security should be by design. Do it from the start. Design for security. There should be regular security assessments as well. and make sure you have real-time threat detection and automated responses. And why this is important is this is just a sample of how a typical simple cloud application looks like. Look at how many connections there are in between these components. All of these, each one of these is a potential vulnerability unless you handle it properly. Okay, so because we are talking to multiple services, numerous services, okay. And we don't just want any of the services or the connections to fail at any point. So with that, I would like to conclude my session. I'm still open for questions, but if it's getting late, you can all feel free to contact me at any point. My contact information is there with the organizers, or even you can connect on LinkedIn as required. But if there's any teaching questions at this point, I'm open to taking them out.
Good evening, Mr. P.R. Mahalingam.
Yes, sir.
Yes, very nice actually your lecture. I am
Thank you.
actually. Here
Thank you.
for data center, what type of security we can make, sir, for data center? It is highly vulnerable. Most of the
Yes.
development servers are available here. And also, what type of penetration testing we have to do to fix any new vulnerability affects our servers or something like that. Can you just agree? Can you tell any points, key points?
Sure. I will do that. So when it comes to data center, physical data centers, there is one important thing that it is under our control. The infrastructure is under our control. So
Okay.
we need to make sure that physical security has to be ensured. That is a proper security guard or a biometric door first. That is the first point of security. And then when we set up these data centers, we need to make sure that there is some level of what we call as replications. And data replication and data fragmenting. So what happens is, if somebody actually shuts down a server, there is a replica, there is a copy available. But more importantly, if the data is properly fragmented, unfortunately, if somebody gets access, they won't get the whole data. They will only get a subset.
We are using SAN, sir, actually, storage area network.
If that, yeah, SAN, it automatically takes care of all of these. So then the thing becomes your network level access. So your firewall should be configured. The SAN's credentials and the SAN's access control should be properly done. The SAN should not have, should not be exposed to the whole internet or even multiple endpoints. Actually, when we have a SAN, it's best to have it behind a very secure firewall. And the recommendation is always to have a hardware-based hardened firewall, not even a software firewall. Okay, software firewalls work for many applications. For SAN, don't even think about that. Let's have a hardware-based firewall. Okay. And for pen test, we have different software tools for doing that. Nessus, OpenPass, Burp Suite is one of the most common one. And what is possible is we can these SANs always expose these endpoints. We can have Burp Suite evaluate the set of endpoints and check whether there is a vulnerability. And if we are using a pen testing tool, we need to make sure it is always kept updated, because Burp Suite and all consistently keep giving updates on new testing protocols.
Zenmap we are using, sir. Zenmap. It is an old tool actually, but still.
That is fine. But I will highly recommend Burp Suite as one of the possibilities.
Okay.
Because that covers almost every pen test item you can think of.
Okay.
Yeah.
Thank you, Mahalingam.
Thank you, sir.
Sir, my question is that sometimes we feel that the services are not available, like for example WhatsApp or Instagram, or they may say that server down, right? So.
Yes.
Or in this case, maybe this is a DDoS attack only, or there may be other attackers also possible through which we can say that this. I mean, there may be other possibilities of other than DDoS, or always DDoS attack is always the issue when we won't be able to get the service of any kind of, we can say that, or cloud platform.
Yes, it need not be always. Actually, if you look at services like WhatsApp or Instagram, they actually have something called as a kill switch. Kill switch means if it suspects any unauthorized or unexpected event, it automatically cuts that service as part of its incident response. Okay, so it could be something like, it need not even be DDoS. Suddenly, one of the virtual machines CPU utilization started increasing. That is actually a possible reason for the kill switch to activate, because as I said, somebody just sent some attachment or something that has an executable which is not detected. Even that is a reason enough for these things to fail. So it may not even be DDoS. Nowadays, that's a reason if you try to send a script file via Gmail in an attachment, it doesn't allow you to do that. It filters it out, because these things are all enough to kill a whole server. So the kill switch is there all across the systems nowadays. Okay. So that is one probable reason. And there are certain cases where these updates, some backend updates, could actually end up pushing a bad configuration. For example, I have the web application firewall. I say that it can tolerate up to 1,000 requests a second. Some update, somebody accidentally removed a 0. So now the configuration now becomes the firewall can handle 100 requests a second. So what happens? Beyond 100 requests, it will just say shut down the system. It is not going to work. So configuration problems can quickly happen. And there are cases where I'm not sure if it is true or not. There was one instance where somebody pushed this thing, staging credentials into production. Should not happen, but if it happens again, a database error happens, it will still shut down the system. So these are all things that happen. But mostly these are kill switches that suddenly stop the system from responding. That's 99% of the time. DDoS is very rare nowadays because the firewalls are extremely powerful. I do see one question in the chat. Yeah, sorry, then. Anything? Yeah. I do see one question in the chat. Can you suggest best firewall to suit education institutions? Education institutions, unless you are extremely, or I would say, unless you're hosting data way too much, we can go for software firewalls, because that's the kind of traffic we expect. So if we look at this, there are certain free firewalls which we use to explore. Okay. It's called NDN or even Fortinet, FortiGate. That is actually a very good firewall as far as education institution purposes are concerned. But they do have some hardware components to that. But Fortinet is a pretty good one, which we typically suggest for many places.
Sir, how do we do scalability testing for, suppose we want to test a IoT network or certain networks?
Which testing, sir? I think I lost you in the beginning.
Scalability.
Scalability testing. Scalability testing, we typically do what we call as a stress test to begin with. So we start with very less number of requests, and then we keep scaling it up. So the testing itself should follow a typical attack pattern to see how many requests it tolerates. And if we are using containerized applications, we actually test it to see how much containers it can actually spin before it fails, before the entire system fails. So scalability testing, typically we actually do the scaling as part of the testing itself. We start with probably 10 requests, make it 100, 200, 500, 1,000, 10,000. We have had cases where we actually tested up to 55,000 requests together to see if the firewall actually breaks at that point.
Okay, thank you, sir. But because why I'm asking this, because the real world traffic is very much different than the testing traffic. Like how many people would be using CD right now? We cannot predict. There are millions of users. So that's my thing.
Yes, if you're considering those kind of scenarios, typically stress testing looks at millions of packets sent at the same time. What the scenario I told you was for a very specific kind of an application that is supposed to be run. 55,000 is a big number for them. But if you look at stress testing an application in the league of something like Google or some such things, their security teams actually run for billions of requests in the same second. So that's how hard they test. They actually run these tests on dedicated networks itself, because the internet should not fail because of this. That's a kind of infra they handle just for testing.
Okay, thank you, sir.
Thank you. Thank you. Yeah, how security is maintained while managing multi-cloud. I didn't touch upon multi-cloud for the reason that it could just go out of control, but it's a good question. So when we run multi-cloud systems, typically what we do is we will have one front-facing cloud. Okay, I mean, for the end customer, for most of the purposes, there will be one front-facing cloud, and the customer's security handling is typically going to be focused on the front-facing cloud. I mean, the authentication, multi-factor authentication, all those things happen there. Between clouds, that is where the major problem comes. Between clouds, nowadays what happens is there are many cloud providers who actually give dedicated links across clouds. So AWS to Azure link direct connects, AWS to GCP direct connects are all available nowadays for a premium, of course. So that is a possibility. But even otherwise, whenever we want to access some data across clouds or from another cloud, we need to be coherent of what protocol they use, what is the level of access they give. For example, I guess a few months back, we developed an application wherein there was a huge computation going on in AWS, but there was a machine learning model hosted on Azure. Okay, because Azure's OpenAI models are available easily. Azure Foundry has a very good repository of models. So we had to do that. And what happened there was, no matter what we tried, that access never came. They use least privilege. Unless you are allowed to access, you cannot. Okay, all clouds do that now. And what we eventually had to do is we needed to create a separate role with bare minimum privileges to execute and return. That's a minimum privilege. You cannot even list the models. I need to give the model ID myself. That is the kind of privilege it was. Attach it to its own access control list, create an API key based on that, and then send it as part of the payload from AWS to Azure. So that is, and that too only over HTTPS. It doesn't even allow me to do anything else. So over there, it actually told me the protocol to follow. So it is already HTTPS, the payload is encrypted. Even if someone is decrypting it, the tokens, the API keys, everything has to match, and you can only run the specific model with the API key. You can only return the particular value with the API key. So that is a kind of tie down it did. Thank you.
Thank you, sir. If not any further queries from the participants, then let's wind up this session. Hope I'm audible.
Yes.
Thank you. So as we wrap up today's exciting session on application security in cloud, let me take this opportunity to extend a heartfelt thanks to Dr. Mahalingam PR for sharing his immense knowledge and practical insights. Today, we explored the unique security challenges in cloud application development and gained a clear understanding of the shared responsibility model and its real-world implications. Thanks to Dr. Mahalingam, we now know how to spot common vulnerabilities in cloud applications like injection flows, broken authentication, and apply best security practices for cloud-native applications, and even learn from real-world security incidents that highlight what works and what doesn't. The session was packed with actionable insights that we can take back and apply immediately. Thank you so much, Dr. Mahalingam, sir. I would like to thank all the participants for your active involvement and interest. Your presence and interactions made today's sessions truly meaningful. Once again, our sincere thanks to Dr. Mahalingam and to all participants for making today's session a success. I'm excited to inform you that tomorrow's first session will also be handled by Dr. Mahalingam. where he will take us through another critical area of discussion, security of third-party integrations with the cloud. We look forward to hosting you again tomorrow, Dr. Mahalingam. And dear participants, we also look forward to your active participation in another engaging learning experience. So that's a wrap. Signing off day 4. Good night, everyone. Thank you.
Thank you.